Like I said, we're going to be going over today the spring 22 exam, something a little more recent. So you guys get a feel for what you're expected to see tomorrow. Okay? Don't forget your exam is at 3 o'clock. And for my students, our exam classroom is in Fretwell 121. Now, we are in the process. How do you want to pass out those tests? You just wait till the end? Okay. We're going to wait till the end for those people for our test number 4. We have the multiple choice questions. We just updated, because we found a slight mistake on one of the keys and stuff, that we just updated the test number 4s, so that has now been pushed out for you guys. So it may have went up by 2 points or something. But we have those multiple choice part of the test for you guys, but you're going to get that at the end of the class. So today, let's get started on the review session. So today, I'm going to be going over the spring 22 exam. And again, get a good feel for this. Now, here's the deal. First part, this is part 1. Part 1, no calculator. No one's allowed to use a calculator for the first hour of the exam. Most people are done with this part 1 within about 30 to 45 minutes, which means we give most people about 15 minutes of still working on part 2 and part 3, but trust me, you won't need a calculator on most of those questions anyway. But no calculator right from the get-go here. So with that, let's just pretend like it is, quote, right here at 3 o'clock, and once 3 o'clock hits, we're going to say, open your exam booklets, and those doors will be shut, and you will not be allowed to be in the exam. This is why we're telling you to show up to the exam early. For my students, I want you there at a few minutes after 2:30 to get your seat. Make sure you got your calculator, pencil, and student ID, or at least your ID number written on a Post-it note. You're not allowed to have your cell phone or any other type of electronic stuff. None of this crap shoveled in your ears. None of that stuff. You are going to be taking an exam. Set yourself up accordingly. All right? There should be enough room to work on the exam. You'll have plenty of space to work on the exam. And especially the free response, you want to go out of your way to be neat and organized on the free response and stuff. Yes? Yes, you are supposed to. But again, usually for a lot of people, that's actually on their phones or whatever, and you're turning in the test, that's when you grab your book bag and stuff, you can go grab your phone. Only then. But yeah, typically, hopefully you got the card thing, but some of you guys, I think they're getting away from the cards and stuff. That's okay, but you are supposed to show your student ID to us as you're turning in the part 2s and part 3s and stuff like that. We will be taking up the part 1s right there right at 4 o'clock, because we have to go submit those things. And again, no one's allowed to use the calculator until we give you the official word, which is 1 hour after the start of the exam. You'll know when we give you that word. All right, so here we go. Here's part 1. Right now, it is, quote, 3 o'clock, and we say, open your test booklets. So even before you start, you put the last name first name last, student ID number, your instructor, and for my students, I'm John Taylor. Okay, good. And then put your section number. For my guys, section 205 or 208. All right, and for the other guys from other people's classes, fill it out accordingly. All right, so we start the test. Now, this is Calculus 2. What do you think this test is going to be about? That's right, Calc 2. All we do is integrate. So there it is, number 1. What are we going to do? Integrate. All right, so what a surprise here. So here we go. So the first thing you want to make sure you're studying is, of course, integral formulas. So here we go. Integrate this guy. And usually the first one's going to be an easier problem. So 3 is a constant, leave it alone. Integral of x squared, add 1 over add 1 is x cubed over 3. Minus 4 is a constant, leave it alone. The integral of 1 over x is the famous natural log absolute value of x. Minus 4. Now here's the $64 question. What is the integral of sine of x? Well, derivative of sine of x is cosine of x. Therefore, the integral of sine of x is negative cosine of x. And then don't forget your plus c. Now, I notice I will each term here, and then I clean it up. So the 3's end up canceling here. This is x cubed minus 4 times the natural log absolute value of x. Minus 4 times a negative cosine makes it a plus 4 cosine of x plus c. And then I go and look at my answers, and it's either between A and B, it looks like here. And of course, look at them. One's a minus 4 cosine, one's a plus 4 cosine. You know we're going to do that to you guys. Make sure you know your integrals of the sines and cosines and stuff. the answer clearly here is going to be B. Does that make sense? But again, notice this fine fact. That's how we're going to set up those multiple choice. So you make sure you have the formulas correctly memorized. Now, take a look at number 2 here. Evaluate this guy, the integral from 1 to 3 of 2x plus 3 dx. Again, no calculator, but it shouldn't be that difficult. Why? The numbers will be nice to plug in. You will be evaluating numbers here. So the integral of 2x, 2 is the constant, integral of x, or x to the first power is x squared over 2, plus the integral of 3 with respect to x would be 3x. No plus c's because you got bounds evaluated from 1 to 3. Of course, I would clean it up here and the 2's end up canceling. So again, fundamental theorem of calculus, plug in top minus plug in bottom. 3 squared plus 3 times 3, plug in top, minus plug in bottom. 1 squared plus 3 times 1. Just be careful. 3 squared is 9, plus 3 times 3 is 9, minus 1 squared is 1, plus 3 times 1 is 3. 9 plus 9 is 18, minus 1 plus 3 is 4, and 18 minus 4 is 14. The answer is D. I didn't need a calculator for that, and you won't either. Does that make sense? Also notice how much room I have on this. You got plenty of room to do the work on the test. You should not need any scrap paper, but at most maybe one sheet for something or other, but that you don't really need scrap paper for this. Okay, so let's keep going. Look at number 3 down here. Evaluate the integral of x times the square root of 1 minus x squared dx. First things first, I don't do square roots, so this is the integral of x times 1 minus x squared dx. Well, it's not a rule I have memorized, so what's your number 1 technique of integration? U sub. I'm going to let u equal 2, and that's by the way to the half a power. Don't forget that guy. So square roots become a half a power, and it becomes u sub. U is inside the parentheses. 1 minus x squared, and that makes du. Your derivative of 1 is 0, minus derivative of x squared is 2x. That's minus 2x dx. There's an x dx already in the problem, so I'll move the constant to the other side. So that makes 1/2 du equals that x dx when I substitute. So when I substitute, this becomes integral of, this part was u, to the 1/2 power, and the x dx, the rest of it gets replaced with a negative 1/2 du. Constants go out front, pull the negative 1 out front, and the du always goes in the back. It should turn into a formula that you have memorized. So here we go. Integrating it, negative 1/2 is a constant. Integral of u to the 1/2, add 1 over add 1, is u to the 3/2 over 3/2 plus c. When I divide by a fraction, I invert and multiply. That's negative 1/2 times 2/3 times u to the 3/2 plus c. Here the 2's end up canceling, so I'm left with negative 1/3 times u. Go ahead and back substitute. U was 1 minus x squared to the 3/2 plus c. And there's my answer. And let's see here, negative 1/3, 1 minus x squared to the 3/2 plus c. Looks like the answer is C. You will notice when I'm doing these exams that I'm really good at getting the answer. I am awful at picking them out of a lineup. So you'll watch. When I'm doing these problems, I'll run through the question, get the answer, and I am methodical in terms of which one I'm picking out. Everybody makes careless errors, including me. I make them more than anybody. But the fact is, the difference is, one, I've graduated. Because I make a careless error, they're not going to take away my doctorate degree. But you make a careless error, you don't graduate. There's a big difference right there. So number 2 is this. Everybody makes mistakes. Everybody. We're human. This is what we do. You've got to figure out where you make your standard careless error, and at that point, slow it down to make sure. Just catch your careless error. There's the difference between my A students and my C students. My A students caught their careless errors. My C students caught about half of them. My F students, they didn't catch anything. So you've got to catch a pattern on this stuff, and it's doable. Just take your time. You got 3 hours. You're not going anywhere. Sit here and enjoy this exam. So far, it's been kind of fun. Let's do the next one. Number 4. The integral from 0 to 2 pi of the cosine of theta d theta. All right, well, again, it's the integral, something we're supposed to have memorized. What is the integral of cosine of theta? Sine theta evaluated from 0 to 2 pi. According to the fundamental theorem of calculus, we plug in top minus plug in bottom. That'll be the sine of 2 pi minus plug in bottom the sine of 0. Now, hopefully you remember at least some stuff about the unit circle, and I recommend you guys at least reviewing the first quadrant on the unit circle. Here is 0, here's pi halves. Now, also, eventually, when you do get a calculator, don't forget to make sure your calculator is in radian mode. Focus on radians, because that's what we typically focus on in calculus. This would be pi 6, pi fourths, and pi thirds. And these are my special points here. Square root of 3 over 2, 1/2. Square root of 2 over 2, square root of 2 over 2, and then 1/2 square root of 3 over 2. And remember, these are my unit circle numbers here. And x is the cosine of the angle, and y is the sine of the angle. And over here at 0, 0 is the same thing as 2 pi, and at that point, x is 1, y is 0. And up here, this pi halves is the point 0, 1. Cosine of pi halves is 0, sine is 1. So here we go. Things I need to know, and I'm showing you this, but personally I have it memorized. So what is going to be the sine of 2 pi? Sine is the y coordinate. So the sine of 2 pi is 0 minus, what's the sine of 0? Well, that's still 0. And 0 minus 0 is 0. We couldn't have made it any easier than that. The answer is obviously B. Does that make sense? Now you can anticipate something like this on the exam. It's a freebie in my mind. It is the idea of what exactly are you doing when you integrate? It comes from chapter 5.1 when we introduced this material. Calculate the integral from -4 to 3 of f of x dx if the graph of f of x is given below here. -4 to 3. And if you remember, when you integrate, you're finding the, quote, area under the curve. So over here at -4, starting here, to 3. 3 is right here. Okay? And this is that geometry aspect of this stuff. Now, there's lots of different ways I can actually do this particular problem, but the way I want you to actually look at it is look at when its area is above the x-axis, it's positive. When area is captured below the x-axis, it's negative. Okay? And you're looking at geometry, area of triangles and rectangles, and in worst case, you'll get is like a circle or a semicircle. So make sure you know your basic rules. Area of a square is, side by side or side squared. Area of a rectangle is length times width. Area of a triangle is 1/2 base times height. Area of a semicircle is 1/2 pi r squared 8. It's pi r squared. So here we go. When I look at this and going from -4, looking at my bounds, to 3, I see a triangle plus I see another triangle, but I'm going to star this guy because where's he located at? Below the x-axis. So this guy should be what? Negative. Plus, I see another little triangle right here. Okay, and this is a small one. Okay, right here. And then plus, and then I've got so I'm trying to kind of subdivide these things. And then I got a square. Does that make sense? And this is the only one that was located below the x-axis between -4 and 3. So, what is the area of a triangle? 1/2 base. The base is 2 units, just counting it. The height comes all the way up here to 4. Plus, this is going to be a negative right here because it's located below the x-axis. And this is, the base is 2, so it's, again, a triangle. 1/2 base is going to be 2. The height of this thing is 2. Plus, here's a little triangle. It's 1/2. The base is 1. The height is 2. Ran out of room there. Plus, the last one is a square, which is length times width, which is 2 times 2. So now, just taking my time on geometry here, this will be 1/2 of 2 is 1 times 4 is 4. A -1/2 times 2 is -1 times 2 is -2 because it was located below the x-axis. Plus, 1/2 of 1 is 1/2 times 2 is 1. Plus, 2 times 2 is 4. So now it becomes basic arithmetic. 4 plus 4 is 8, plus 1 is 9. 9 minus 2 is 7. The answer is D. We like that geometry aspect, but you're calculating the area under the curve. Here, 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 and here. And this one was located below the x-axis, so I made that negative. That was the deal. Number 6, compute the second derivative where f of x equals the integral from 0 to the sine of x of e to the t dt. Find the second derivative. Well, this is part of that fundamental theorem of calculus stuff here. So remember, when you take the derivative of an integral from a to x of some kind of function f of t dt, you pretty much, the derivative and the integral cancel and you're left with f of x. This was called the fundamental theorem of calculus. This was what Dr. Stewart in his textbook called part 1. But this was the basic rule, and then you had the chain rule version of that rule. The derivative with respect to x of the integral from a to some kind of function g of x of f of t dt. Again, the derivative and integral cancels, you're left with the function, in this case g, but with the function f of x, they cancel, but with g of x plugging in for t. So that would be f of g of x. You plug in literally the function on the bound in for the t, but then chain rule times derivative inside, g prime of x. This was the chain rule version. Again, just trying to remind you of your basic rules. This is why you study the old final exam. So, I want the second derivative. Well, first, I got to have the first derivative. So, f of x is equal to the integral from 0 to the sine of x of e to the t dt. Then, f prime of x would be the derivative with respect to x of the integral from 0 to the sine of x of e to the t dt. And just like we mentioned here, the derivative and the integral are going to cancel. So you're left with e with the function sine of x plugged in for t, sine of x, but it's the chain rule, times the derivative of the inside. What's the derivative of sine of x? Cosine of x. Congratulations, you found the first derivative. So here it is. F prime of x is equal to e to the sine of x times the cosine of x. But luckily, we all passed calculus 1, so we should be able to do the next part. Because what the real question was what is the second derivative? So this is e to the sine of x times cosine of x. So I'm going to use the product rule. Derivative the first times the second plus the first times derivative the second. Derivative the first. Derivative of e to a function is e to the function, e to the sine of x, times derivative of the exponent, times cosine of x. Derivative the first times the second times cosine of x, plus the first, e to the sine of x, times derivative of the second. What's derivative of cosine of x? Negative sine of x. You want to clean that guy up, so this gives me f double prime of x is equal to e to the sine of x times cosine of x makes it a cosine squared of x. Positive times a negative is a negative, e to the sine of x times sine of x. Okay? Does that make sense? So now, let's go find our answer. E to the cosine squared, e to the sine of x times cosine squared of x, that's there. It's a minus, okay, e to the sine of x times sine of x. Looks like the answer is A. And again, I will slow down and double check to make sure that's really my guy. Does that make sense? Questions? Again, while we study the old final exams. Here's another one that seems to throw my students fits in the class on Calc Test 1 and Test 2 every time I gave it to them. Here it is. Find the, given that the limit as n approaches infinity of n going from 1 to n of the natural log of 1 plus 2i over n times 2i is equal to which definite integral? All right. So, remember the rules. Number 1, delta x by formula is b minus a over n. I'm looking for a number divided by n. xi is equal to a plus I times whatever that delta x was. Okay? And the integral from a to b of f of x dx is equal to that limit as n approaches infinity of the sum as I goes from 1 to n of the f of x I, this guy here, times delta x. So when I look at this problem right here, the first thing I got to figure out is who is delta x? Delta x has got to be a number divided by n being multiplied by my function. It's pretty obvious. Can you tell me, because this is detective work, what is the delta x equal to? Delta x has got to be that 2 over n, number over n, 2 over n. All right, but delta x is equal to b minus a over n. That automatically tells me, since the n's will end up canceling here, that b minus a has got to be equal to 2. That is important information right there. The difference on my balance between a and b has to be 2 units. Does that make sense? I don't know what a is yet. I don't know what b is, but the difference between a and b has to be 2. Immediately from that, I can start eliminating some of my answers. Look at your balance. What's the difference between 3 and 1? 2. All right, that's a good one. What's the difference between 1 and 2? This is wrong. Okay. 1 and 3 is 2. Oh, there's 1, 2 and 1. What's the difference? 1. What's the difference between 3 and 2? Well, I've just eliminated 3 out of my 5 answers. Now I got a 50-50 shot on getting this guy right. Does that make sense? Just on analyzing the balance. Let's continue on. Now, that means that the functional part has to be the rest of it, which is this part here. The natural log of 1 plus 2i over n. Now that I know this, that b minus a is equal to 2, and I know that xi is equal to a, I'm not sure what a is, plus I times delta x. I do know what delta x is. So xi would be equal to a plus I times delta x, which is 2 over n. So xi would be a plus 2 times I over n. Now, look at my 2 answers. Here's the nice thing about it. What do I happen to notice? On both the two answers, what is the a part? A, from these 2 guys right here, I can tell you that a has to be equal to what? 1. So if a equals 1, I'm going to plug it in here. So xi is equal to 1 plus 2i over n, which means when I take my function part, the function, it'll be the natural log. When I see a 1 plus 2i over n, I get to replace it with just x. And there it is right there. That gets x, so that becomes the function has to be the natural log of x. So this becomes the integral. And if a is equal to 1, this makes b equal to what? Remember, b minus a equals 2. b minus 1 equals 2. What does a have to be? 3. This will be the integral from 1 to 3 of the natural log of x dx, which makes the answer C. Did that make sense? And notice it's detective work. It's not designed to be hard, but you got to know some stuff about it. Yeah. Xi is a plus I times delta x, and you drop the little I when you're trying to convert it to an integral, you just replace it with x. Take a look at this next guy. Again, notice how much space I've got to do these problems and stuff. So here we go. Number 3 here. The sequence AI is where AI is equal to 8n squared minus 2n divided by 4n minus 2n squared. They want to talk about convergence. Well, here's the beauty of it. This is chapter 8. It was just on your last test just a couple of days ago. So here we go. To figure out if a sequence converges or diverges, all you do is take the limit as n approaches infinity of an. So this will be the limit as n approaches infinity of 8n squared minus 2n divided by 4 minus 2n squared. Now, officially, I could do L'Hopital's rule on this guy, and that's fine if I needed to show my work. But I've been trying to train my class in doing this. Well, notice, what's the degree of the top? 2. Degree of the bottom is 2. And it's called the horizontal asymptote theorem. When the degree of the top is less than the bottom, the answer is always 0. When the degree of the top is the same as the bottom, it's the ratio of leading coefficients. And when the degree of the top is bigger than the degree of the bottom, the answer is either plus or minus infinity, and I actually have to work out the numbers to figure out what the sign is going to be to get what kind of infinity I'm going to get. But in this example, since the degree of the top is the degree of the bottom, it's the ratio of leading coefficients, which is 8 over negative 2, which reduces to negative 4. So we would say it converges to negative 4. Now, and so the answer is clearly A there. But if I needed to show my work, now the other thing that I'm trying to do with you guys is this. I'm trying to do every problem on this exam as if it was a free response question. I'm not skipping any steps on this stuff. So if I had to show my work on this one, well, you plug in infinity, you get infinity over negative infinity. You L'Hopital rule at least once or twice. Things will cancel out, and you end up getting the negative 4 out of the thing. That's how you show your work on that. Does that make sense? Questions? Yeah.
So we wouldn't be allowed to use it for this type of piece if it was in that first piece.
Well, it depends. Usually this type of question is going to be on multiple choice, so shortcut is perfect fine. It is rare, but you never know that something like this would show up on the free response. Well, the free response, no, we would still give you credit for that because it's a no-brainer. But if I really wanted to show my work and people were paying me to do this, I would actually do L'Hopital's rule twice on. All right. Take a look at this guy here. So here's another one. Partial fractions. So find the value of b. So I want to show you this one because it will save you some time. Find the value of b in the partial fraction 4x minus 9 over x minus 1 times x minus 2 is equal to a over x minus 1 plus b over x minus 2. Well, if I'm trying to figure out the partial fractions a and b, I'm going to take my equation called the annihilator method and multiply by my common denominator, which is x minus 1 times x minus 2, all the way across. Well, here the entire denominator cancels. You're left with 4x minus 9 equals, here the x minus 1 cancels. You're left with the a, the numerator, times x minus 2, plus here the x minus 2's cancel. You're left with b times x minus 1. Now, in the traditional way, we would have to find a and b, so I would use my annihilators, my zero terms. I would have x equals 1 and x equals 2. But in a multiple choice question, they went out of their way to say, hey, find the value of b. So I don't want to eliminate b, I want to eliminate a. What eliminates a? What value of x? 2. So you don't need to find both of them. Just use the guide that basically eliminates the a so you can solve for b. I'm going to let x equals 2. Plugging it in, this will be 4 times 2 minus 9 equals a times 2 minus 2 plus b times 2 minus 1. 4 times 2 is 8, minus 9 is negative 1, equals a times 2 minus 2 is 0, plus b times 2 minus 1 is 1. That goes away, that was the point, and that tells me negative 1 is equal to 1 times b is b. Pretty much b's got to be negative 1, and so the answer is E, b is negative 1. Compute the integral from 0 to 2 of x times e to the x dx. Now, this is the final exam. We are expecting you guys to look at some classic common integrals that we've done. Basic rules, use substitution, and section 6.1, integration by parts. You should recognize this as integration by parts. Number one, it's not a rule I have memorized, x times e to the x. I know how to integrate e to the x, but you shovel anybody in front of them, it's either going to be u substitution, which I would let u equal to the exponent, x, but in u substitution, never let u equal x. It's stupid, you don't really change anything. The other thing I've got is integration by parts. This is an integration by part problem, so remember your formula. You will see them again, integration by parts. And that is the famous, the integral of u dv is equal to uv minus the integral of v du. So here, you got to figure out what you're going to let u equal to and what you're going to let dv be. Do not forget the Lytle principle. This was basically your steps on what you should let u equal to with integration by parts. Lytle, L-I-A-T-E. U, logarithms, always first. Then if you don't have log, try inverse functions, I. If you don't have that, then A, algebraic term. If you don't have that, then T, trigonometric functions. If you don't have that, the last thing in the world you ever want to let u equal to is exponentials. So with this, what am I going to let u equal to? Well, again, I don't have any logs in this problem. I don't have any inverse trig, but I do have an algebra, x. I'm going to let u equal x, and dv should be the part you can actually integrate. And that'll be the rest of it, e to the x dx. I also told my students that you want to let u equal to something, when you take its derivative, it goes away. There's a classic what you should let u equal to with integration by parts. And what is the derivative of x? So du would be what? 1 dx. So what would v be? The integral e to the x, that's something you should actually have memorized. What's the integral e to the x? E to the x. So there's your u du dv v. Again, I'm showing you this because you can anticipate something like this also on the free response part of your exam. And now I'm going to plug it into my formula.
u times v, which will be x times e to the x, minus the integral of v, which is e to the x, times du, which is 1 dx. And I want you to see the literal substitution into the formula. So this gives you x times e to the x minus, and what is the integral e to the x? E to the x. No plus c's on this one because I happen to have bounds. So I put my bounds up there from 0 to 2, and then I apply the fundamental theorem of calculus. Just be careful. Plug in top minus plug in bottom. Plugging in top, 2 e to the 2 minus e to the 2, minus plug in bottom, 0 times e to the 0 minus e to the 0. I want you to see, literally I'm plugging top minus plug in bottom. Where most students who messed this problem up, they messed it up on the basic algebra. They got it all the way down to here and then fumbled the ball. So, clean it up. Here it is. What is 2e squared minus e squared? How many e squared you got? 1e squared. 2e squared minus 1e squared is just 1e squared. Minus e to the 0 is 1, but times 0 is still 0. Minus e to the 0 is 1, that'll be minus 1. So cleaning it up, this will be e squared. 0 minus 1 is negative 1. Minus negative 1 makes it plus 1. So there's my answer. E squared plus 1. The answer was B for this problem. Does that make sense? Take a look at this guy right here. Now this one, again, yay, it's another problem from our chapter 8 sequence series. We're talking about the Taylor polynomial. Now this messed up a lot of students because we usually, when you get functions like e to the 2x, it's easier to use the Maclaurin series, but no. What do they want you to do? They want you to do the Taylor series centered at what? A equals 1. So you make sure you have the Taylor series formula memorized. So here it is. F of x is equal to f of a plus f prime of a times x minus 1 plus f double prime of a over 2 factorial times x minus 1 squared plus dot, dot, dot. That's your Taylor series formula. So we're going to have to generate this guy. This is not a Maclaurin series that you can just memorize. You got to build this one. So we're going to at least give you one that you're going to have to build. So here it is. My function is f of x, which is e to the 2x. I need to know what the first derivative is. Hurt yourselves. What's the derivative of e to the 2x? E to the 2x times 2, which is, like you said, 2e to the 2x. So what is your second derivative? Well, derivative of 2e to the 2x, hold the 2 there. Derivative of e to the 2x is e to the 2x, again, times another 2, which makes it 4e to the 2x. And then you can basically, you can do one more derivative if you need to. Third derivative. And what's the derivative of 4e to the 2x? Well, 4 is a constant. Derivative of e to the 2x is e to the 2x times 2. That makes it 8e to the 2x. Does that make sense? But watch. What is my centering point? 1, not 0. It's 1. So I need to know what f of 1 is, what f prime of 1 is, what f double prime of 1 is, and what f triple prime of 1 is. Plug in 1, 2 times 1 is 2, that'll be e squared. Plug in 1 here, 2 times 1 is 2, that would be 2e squared. But for your second derivative, plug in 1, 2 times 1 is 2, that'll be 4e squared. And plugging in 1, 2 times 1 is 2, e to the e squared times 8, that would be 8e squared. Does that make sense? These are my guys. So now plug into my formula right here, just to show you. E to the 2x centered at 1 is going to be f of 1, f of a, which is 1, which is e squared, plus f prime. F prime of 1 is 2e squared times x minus 1. Plus, what about your second derivative at a? That is 4e squared divided by 2 factorial times x minus 1 squared. But I didn't write down the third term, but you should be able to catch the pattern on that. That would be 8e squared over what? 3 factorial times x minus 1 cubed. Just want you to see patterns plus dot, dot, dot. Because it does, it's infinite series, it keeps on going. So clean this guy up. Well, let's see here. I don't actually think I need to clean this guy up. I think I actually have him. Let's see here. It's e squared, so it's either got to be d or e here. And it's 2e squared times x minus 1, 4e squared times x minus 1 squared over 2 factorial, 8e squared times x minus 1 cubed over 3 factorial. I believe I found my pigeon. It is, the answer is D. Does that make sense? But you know where people screwed this problem up at, right? Well, the Maclaurin series for e to the x is 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial. They try to plug in a 2x for the x, and then they try to find that answer. And mathematically, we gave that as one of the answers. But that is the Maclaurin series for e to the 2x centered at 0. Are we centering this problem at 0? No, we're centering at 1. So that's why this is not the right answer. This is, which makes it E. Makes it answer D. Here's another problem from chapter 8. 25% of your exam is going to come from chapter 8. Here it is. Which of the following statements is or is not correct here? Which of the following is correct? So the first one. Now watch. I'm not going to work it completely through. All I've got to figure out is if it's going to converge or diverge here. This dude here. Now I've got the sum as n goes from 0 to infinity of 5/4 raised to the n, and we say it diverges. Well, what kind of series is this guy? You got it. A geometric series, and you'll notice on this geometric series here that it starts at 0. So here's the formula. Sum as n goes from 0 to infinity of ar to the n. That's the special rule when you start at 0. A is going to be equal to 1 in this problem. R is the number that's being raised to the n power. That's 5/4. But happen to notice that the absolute value of R, absolute value of 5/4 is 5/4, which is greater than 1, which means it does what? Diverge. This is a geometric series as mentioned, but it's going to diverge because your R is greater than or equal to 1. So this is true. Big check mark there. So the answer is 1, and maybe something else. I can pretty much knock out D and E on this problem. Now let's take a look at this guy right here. This one right here, this one is the sine squared of n over n cubed. Now sine squared makes them positive, but the sum as n goes from 0 to infinity of the sine squared of n over n cubed. Sine bounces between -1 and 1. When you square it, bounces between 0 and 1. So this guy is less than or equal to, the most sine squared will ever be will be 1 over n cubed. Now this guy's got a name. What do you call this guy? P series. P is equal to 3, which means he is going to converge. This guy is less than convergent and he's positive. So by the direct comparison test, this thing is going to converge. This is a winner. So the answer is 1 and 2. And so I got it now down between A and C, and it all depends on this guy here. The sum as n goes from 1 to infinity of -1 to the n times 3n over 2n plus 1. Now this is an alternating series, so I shall use the alternating series test because I have a brain. But part of the alternating series test is this. I happen to notice the BM part, the sequence of your series without the alternation is the 3n over 2n plus 1. And I happen to notice, and I'm going to put that word notice, when I take the limit as n approaches infinity of bn, that'll be the limit as n approaches infinity of 3n over 2n plus 1. What do I get there? That's kind of stuff you do in your head. Since degree of the top is equal to degree of the bottom. What is it? You can L'Hopital rule it if you want to, but you get 3/2. But this is the alternating series test. If it was going to converge, what has it got to go to? This thing is not 0, which means by the alternating series test, its thing is going to diverge. Does that make sense? But they say it converges. This one is wrong. So the answer is only 1 and 2. So the answer is 1 and 2 only. The answer is A. Does that make sense? Questions? This particular semester, they gave us 15 multiple choice questions for part number 1, and I have an hour to do it, but I'm working pretty good on this one, and I've already used up about, well, I started late here, so I've used up about 40 minutes of this thing, but here's another one. I got 3/8 over 100 plus 3/8 over 100 squared plus 3/8 over 100 cubed plus ... And it's just the same thing as 0.383838. Remember, no calculator on this thing. So we want to figure out from the geometric series what this thing's going to go to. So remember on the geometric series, and I'll write it down for you, the sum as n goes from 1 to infinity of a over 1 minus r. It is going to do one of two things. it's going to converge to, because we know exactly what it adds up to be, 1 over a over 1 minus r, provided the absolute value of r is less than 1, and it's going to diverge if the absolute value of r is greater than or equal to 1. This is your traditional geometric series, okay? But when you have a geometric series that's been written out, here's the deal. You can read A right off of it. A is the first term in the pattern, which is 38 over 100. The R is the number you multiply by the first term to get to the second term. What do I need to multiply by 38 over 100 to get 38 over 100 squared? 1 over 100. And I double check. What do I need to multiply by 38 over 100 squared to get 38 over 100 cubed? Another 1 over 100, right? So your R is 1 over 100. So now I've got the A and the R. Absolute value of R is less than 1, so we know this thing is going to converge. And we're going to know it's going to converge to the formula A over 1 minus R. That would be 38 over 100 divided by 1 minus R, which is 1 over 100. So this is 38 over 100 divided by, what's 1 minus 1 over 100? Well, 1 is 100 over 100. 100 over 100 minus 1 over 100 is 99 over 100. And then you invert multiply. This is 38 over 100 times 100 over 99. That cancels, so you're left with 38 over 99. And if you happen to notice the pattern of the repeating decimal, 0.38, 38, 38, I could have looked at it until the answer is going to be the repeating part, which is 38, then it repeats, and it's 2 digits, so it's going to always be over 99. So I could have looked at it until the answer was going to be D. It's 38 over 99. Yeah. A r to the n minus 1, or, I mean, that was our traditional geometric series. Okay, I read it, I see what you're saying. A r to the n minus 1. I kind of jumped the gun on that one. So you're right, and it's equal to A over 1 minus r. There you go. This is your classic geometric series. The other geometric series, the sum as n goes from 0 to infinity of A r to the n. Well, you start at 0 or you start at 1, but you're right. There you go. Thank you. Take a look at this guy, number 14. Again, I'm treating every problem, so I'm going way out of my way to talk about this stuff of how to do it. And trying to show you like it's a free response question. This is the integral from 2 to 5 of 1 over x minus 2. You should recognize this guy. What's this guy's name? It is an improper integral. What makes him an improper integral? The 2 on the bottom. Because if I plug in 2, look at the function, 1 over x minus 2. When I plug in 2, I get 0 in the denominator, which I can't divide. So how do we show work on an improper integral? Now, this is multiple choice, so I don't have to go this detailed on it, but I'm doing this to help you prepare for the final exam. So I'm going to take my limit, pick my favorite letter, A, approaches 2, but we're integrating from 2 up to 5, so it'll be 2 on the plus side of, here it comes, the integral from A to 5 of 1 over x minus 2 dx. Now I got to evaluate this guy. This will be the limit as A approaches 2 from the plus side. Now, this is something you should be able to integrate in your head. It's U substitution in your head. What's the integral of 1 over x minus 2? Well, U would be x minus 2, du equals dx. It's 1 over U, which is natural log absolute value of x minus 2, evaluated from A to 5. That, you didn't have to write out the U substitution. You should do that one in your head. Fundamental theorem of calculus, plug in top minus plug in bottom. Limit as A approaches 2 from the plus side of the natural log of plug in top, 5 minus 2, minus plug in absolute value of A minus 2. So cleaning it up, this is the limit as A approaches 2 from the plus side of the natural log of 5 minus 2 is 3, minus the natural log of 8 minus 2. Okay? Now, first rule of limits is plug it in. So this, when I plug it in, I get the natural log of 3 minus the natural log of A, which is 2 on the plus side, minus 2 makes it 0 on the plus side. Now be careful on this one. Watch your signs. Something you should know. What is the natural log of 0 on the plus side? What is it equal to? Negative infinity. Remember your natural log of x graph. Y equals the natural log of x. goes to the point 1, and goes straight down as I get close to 0, and goes straight up. So the natural log of 0 on the plus side is going towards negative infinity. So this is natural log of 3 minus negative infinity. And so that's the natural log of 3 plus infinity, which makes the answer infinity divergent. And look at my answers here. They like to do the divergent, but on occasion they'll ask which way you're diverting. You're going to divert it to positive infinity or negative infinity. The answer for this one is positive infinity. Does that make sense? Because the minus the negative. And while they're at it, they decided to do another improper integral. So let's see if we can do this guy. This one is what I call a type 1 improper integral, and that's because of the infinity on the bounds. So again, pick my favorite letter, take the limit as a approaches infinity of the integral from 2 to a of x squared e to the 8 minus x cubed dx. Now before I evaluate that guy, it's still all about integration. So come over here on my little sideboard. This is the integral of x squared e to the 8 minus x cubed dx. This is not a rule I have memorized. So my number one technique of integration is u sub. What are you going to let u equal to? The exponent with e's 8 minus x cubed. That means du equals derivative of 8 is 0. Derivative of minus x cubed is negative 3x squared dx. Move the negative 3 to the side, so it's divided by negative 3. Negative 1/3 du equals x squared dx, which is in your problem. So this turns into the integral of e to the u. And the x squared dx gets replaced with a negative 1/3 du. Negative 1/3 goes out front, du. Integrating e to the u, you get e to u. This is negative 1/3 e to the u. And then I back substitute. This will be negative 1/3 e to the u, which is 8 minus x cubed. There's my integral. So I'm back over here. This is now the limit as a approaches infinity of negative 1/3 e to the 8 minus x cubed, evaluated from 2 to a. According to the fundamental theorem of calculus, you plug in top minus plug in bottom. So this is equal to the limit as a approaches infinity of negative 1/3 of e to the 8 minus a quantity cubed minus negative 1/3 e to the 8 minus 2 cubed. I'll clean them up. 2 cubed is what? 8. 8 minus 8 is 0. So this ends up becoming e to the 0, which is 1. So this is the limit as a approaches infinity of negative 1/3 e to the 8 minus a cubed. And minus makes it plus 1/3. Now you evaluate this integral. And again, first rule of limits is plugging it in. So evaluating it, plugging in your infinity, this would be negative 1/3 e to the 8 minus a infinity, plugging in infinity, cubed plus 1/3. Now follow the math. What is infinity cubed? Infinity. What is 8 minus infinity? Negative infinity. So this is negative 1/3 e to the negative infinity plus 1/3. However, what's e to the negative infinity? That's something else you're supposed to know. What's that? 0. E to the negative exponent is 1 over e. E to the infinity is infinity. So 1 over e to the infinity is 0. E to the negative infinity is 0. So this part goes to 0 plus 1/3 is 1/3. The answer is convergent to 1/3. There's all my work. The answer is A. It converges to 1/3. Does that make sense? Now, I did this with great explanation, and I still finished this thing up in 45 minutes. Okay? So I'm going to move on to part 2. However, I have to turn in part 1. I double check it, make sure I filled out all my parts on this thing. I turn it in, and now I still got 15 more minutes before I'm allowed to even think about a calculator. But most of it I can still do without a calculator. So I fill this thing out. I got another OpScan sheet that I'm going to fill on this guy. So let's pick it out. So here's number 1. This is what we're going to do in terms of table integration. We're either going to give you the table formula, or we're going to give you a choice of table formulas and let you figure out which one's going to be. But you don't have to memorize the table formula. We're going to give it to you. So this is table integration. So here we go. And I don't need a calculator for this. So if I look at this guy, I'm trying to integrate x times the square root of x to the fourth minus 64 dx. This is the forms involving u squared minus a squared, which is what they gave me here. So when I do my substitution, the u squared would be inside the square root, that's x to the fourth, and the a squared would be equal to 64. Does that make sense? This is how you set up these table formulas. Then from the u squared, you find u. I take the square root of both sides, so if u squared is x to the fourth, u would be x squared. And if a squared is 64, that makes a equal to 8. Didn't need a calculator for that. But remember, this is still u substitution. That's why it's the number one technique of integration. So, if u equals x squared, that means du is equal to 2x dx. Now, with table integration and the more advanced type of u substitution integration, solve for the dx. I'm going to move the 2x to the side by dividing by 2x on both sides. I get 1 over 2x du is equal to dx. So when I substitute, so watch this. This is the integral of x times the square root of x to the fourth minus 64 dx. When I substitute, this is the integral. This is x. This is square root of, but the x to the fourth minus 64 is the u squared minus a squared part. And the dx gets replaced with 1 over 2x du. What happens to my x's? They're going to cancel. Constant goes out front, so this is going to turn into 1/2 the integral of the square root of u squared minus a squared du. So out of all these three formulas up here, which one do I actually need? The top one. There's no extra u squared out front, there's no u on the bottom. So keep that constant out front, that's 1/2 bracket there, and then I plug in my formula. It's 1/2 u times the square root of u squared minus a squared, minus a squared, the natural log absolute value of u plus the square root of u squared minus a squared. Okay, and then close the absolute value there, and then you'll plus c at the end there. Sorry, I had to squeeze it in, but there it is. And now, clean it up. This is equal to 1/2 out front times 1/2. What was u equal to? Back substitute. U was x squared times the square root of u squared, which was x to the fourth, minus a squared, which is 64, square root of x to the fourth minus 64, minus what was a squared equal to? 64, times the natural log of the absolute value of, this was a u was what? X squared plus square root of a squared minus u squared, that's the square root of x to the fourth minus 64, close bracket, close parentheses, close absolute value, close bracket, plus c. Now, one last thing. They don't like a bunch of parentheses around these guys, or brackets, so they typically clean them up. To clean it up, there's two terms here. This is your first term, this is your second term, so distribute your 1/2, and you're going to end up getting this. What's a half times a half? 1/4. So this will be 1/4 x squared times the square root of x to the fourth minus 64. Minus, what's half of 64? 32 times the natural log absolute value of x squared plus the square root of x squared minus 64. And then plus c. There is my final answer right there. It's 1/4 out front minus, the only one that's got a 32 has got to be this guy. X squared, make sure all the other terms are matching up there, and I figured out my answer. The answer is C. Does that make sense? Question? Yeah.
Question like this, could you be able to like mentally look at it and like realize which formula is
No, well, mentally, which formula you're going to use, yes. What is going to be your answer? No, we're going to screw that up for that.
Say like you skip that problem earlier on, it's like say you don't know how to do it, and then like you go back later on and like you remember how to do it. Like I was gonna say like what if that's
Well, as long, yeah, but this is part 2, so you have that option. On part 1, that first hour, I'm going to take that sucker up. So no, you don't have that option on part number 1. You got to get it done, move on. Part 2 and 3, you can always go back to it as long as you turn it in by the 3-hour mark. Got it.
it's 2 hours total combined of part 2 and part 3?
Yeah, we give that to you all at one time. Yeah, question. Where do I get du equals 2x dx? So when I let, in this problem, this is forms involving the u squared minus a squared. U squared was x to the 4th. So I took square root both sides. So u equals x squared, but it's u substitution. So after you do u, you got to do du. The derivative of x squared is that 2x dx. That's where it came from. All right, here's one right here. All right, find the area of the region bounded by the curves y equals 5 minus x squared and y equals 1. Now, I don't really need a calculator for this one, but you may need one. 5 minus x squared. If I graph that, that's x squared parabola. Negative, it's upside down, right? Upside down parabola shifted up by 5. 1, 2, 3, 4, 5. There it is, upside down parabola. This is your y-axis right here. So it's going to look like this. Okay, upside down parabola. Y equals 1, that's real easy. That's a horizontal line right there at 1. So this is y equals 1. So you got clearly the top and the bottom. Does that make sense? And now if you look at where these guys meet up at, you set them equal to each other. 1 is equal to 5 minus x squared. I'm going to add x squared to both sides just to show you. That gives me x squared plus 1 equals 5. Subtract 1 from both sides, x squared equals 4. Square root of both sides, x is equal to plus or minus 2. So this is going to have to be down here at negative 2 and at positive 2. These are my points of intersection. Those are my bounds. Does that make sense? Now, I want to find the area in the curve. Well, if you remember, area is equal to the integral from a to b of your top function minus the bottom function dx. Notice as I'm doing this exam, I'm also writing down formulas you need to have memorized. So this would be the integral. The top function is the 5 minus x squared minus the bottom function is the y equals 1 dx of your bounds negative 2 to 2. Clean them up. This integral from negative 2 to 2. 5 minus x squared minus 1 is actually 4 minus x squared dx. Now integrate. Integral of 4 with respect to x would be 4x minus integral of x squared is x cubed over 3 evaluated from negative 2 to 2. Fundamental theorem of calculus, plug in top minus plug in bottom. 4 times 2 minus 2 cubed over 3 minus 4 times negative 2 minus negative 2 cubed over 3. Just in case they put this on the on the multiple choice no calculator part. Here we go. 4 times 2 is 8 minus 2 cubed is 8 thirds minus 4 times 2 is negative 8 and this is minus negative 2 cubed is negative 8 thirds. So cleaning this up, this is 8 minus 8 thirds. Minus a minus makes it plus 8. A minus makes it plus, and then distributing that negative is back to minus 8 thirds. So this is 16 minus 16 thirds. And then I can go for that common denominator bit. So 16, when you multiply by 3, is what, 48? So this is 48 thirds minus 16 thirds. 48 minus 16 is how much? 32 thirds. Now here is the beauty of this particular problem. The answer is it. At some point, may not be right now, it may be in 10 minutes from now or whatever when I'm working on this exam, I will be eventually, because this is part 2, allowed to use my handy dandy teddy bear of a calculator here. So, and now that I got this thing set up, I would be remiss, I would be a moron if I didn't double check my stuff on the calculator knowing that my life depends on how well I do on this exam. So, math number 9, because I am allowed to use my calculator, this is from negative 2 to 2 of your top function, which is 5 minus x squared, close parentheses, minus the bottom function, which was 1, dx, x, there we go, and I get 10 and 2/3, which is 32 thirds. I'm feeling much better about my problem now because I'm allowed to use a calculator. Just to let you know, but maybe I didn't get to use the calculator then, I would go back and use the calculator. Try this. Again, another reason why you guys want to study old exams. So don't let this be the only old exam you guys study. Do this, guys. Find the average value of this function, f of x equals 6x squared minus 1 on the interval between negative 1 and 3. All right. Formula you need to have memorized. It's going to be on the exam. The average value formula is 1 over b minus a times integral from a to b of f of x dx. Yes, that is one we expect you guys to have memorized. A is equal to -1, b is equal to 3. Okay? So, plugging in my numbers here, this will be 1 over 3 minus -1 times integral from -1 to 3 of 6x squared minus 1 dx. Clean them up. What is 3 minus -1? Minus negative makes it plus, so 3 plus 1 is 4. This will be 1/4. The integral from -1 to 3 of 6x squared minus 1 dx. Honestly, I expect this kind of a problem to be on the no calculator section, so let's see if we can do it. So that'll be 1/4 times the integral of 6x squared. 6 is constant, integral of x squared is x cubed over 3. Minus the integral of 1 with respect to x would be x. And I got bounds between -1 and 3. Cleaning them up, this is 1/4 times 6 divided by 3 is 2x cubed minus x from -1 to 3. According to the fundamental theorem of calculus, I'll plug in top minus plug in bottom. This would be 1/4 times 2 times 3 cubed minus 3 minus 1/4 times 2 times -1 cubed minus -1. The only problem I got is making sure I don't make some bonehead careless error. So this would be 1/4 times 3 cubed is what? 27. 27 times 2 is? 27 times 2 is 54. Thank you. 54 minus 3 is 51. Minus, here we go, 1/4 times -1 cubed is -1 times 2 is -2. Minus 1 makes it +1. -2 plus 1 is -1. Cleaning them up, this is 51, over 4. A negative times negative is a positive plus 1 over 4. That's equal to 52 divided by 4. And 52 divided by 4 is, something you should know, 13. The answer is 13. And I didn't need a calculator for that. But you know what I do have? It's on the calculator section of the exam. So I'm going to double check this thing because I have a brain. So this would be 1/4, that's that 1 over b minus a, times math number 9, the integral from -1 to 3 of 6x squared minus 1 dx. And let's see. Oh, I'm feeling much better about my answer now. The answer is 13. If you're allowed to have the calculator, use it. But what was the real question on this one? Did you remember the average value formula? I'm sorry, question. Where's the question at? Oh.
My question got answered.
Oh, okay. All right, okay, good. All right. All right. What are the other formulas you're going to need to know for this example besides all the other ones we've covered? You better know Simpson's rule, trapezoidal rule, and midpoint rule. I can't tell you which one you're going to get, but you're going to get one of them. Okay? And you got to show me the work. So this is how we give you guys questions where the program really doesn't help you out on your calculator. So here we go. This one is a Simpson's rule problem. So we want to use Simpson's rule for 4 partitions. So n is equal to 4. And we're trying to estimate the integral from 0 to 12. So remember, your delta x formula is still b minus a divided by n. A is equal to 0, b equals 12, so that's 12 minus 0 divided by n. N was 4. That's 12 over 4, which is equal to 3. Now they gave me more information than I needed here. Delta x is equal to 3. We're supposed to use 4 partitions, so here I go. I'm starting at a, which is 0. There's my a. I go over 4. I go over delta x is 3, I get 3. I go over another 3, I get 6. I go over another 3, I get 9. I go over another 3, I'm going to get 12. Does that make sense? 1, 2, 3, 4 partitions. The formula for Simpson's rule for n partitions is delta x divided by 3 times, remember the pattern. It was f of a plus 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3 plus dot 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 plus 4 times f of x n minus 1 plus f of b. This was the Simpson's rule formula. Trapezoid rule formula was delta x divided by 2 times f of a plus 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3 plus dot 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 plus 2 times f of xn minus 1 plus f of b. The midpoint rule is just delta x times f of the midpoint of your first partition plus f of the midpoint of the second partition plus dot 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 plus f of the midpoint of your last partition. So you've got 3 formulas on this guy. So here we go. These are my partitions. Delta x was equal to 3. So the number of partitions, this was for 4 partitions. S4 would be delta x, which is 3, over 3 times f of a. A was 0, b was 12. F of 0 plus 4 times f of 3 plus 2 times f of 6 plus 4 times f of 9. This is my last partition before my endpoint plus f of b. B was 12. Okay? So it's this 4, 2, 4 pattern internally. And remember, with Simpson's rule, n always had to be even, which with 12 partitions we had. So 3 over 3, which is pretty much 1, times f of 0. F of 0 was 2. Plus 4 times f of 3, which was 5. Plus 2 times f of 6, which was 0. Plus 4 times f of 9, which was 3. Plus f of 12 equals 2. So 3 over 3 is 1 times, well, 2 times 0 is pretty much 0 there. This will be 2 plus 4 times 5 is 20, plus 4 times 3 is 12, plus 2. Let's see here. 2 plus 20 is 22. 22 plus 12 is 34, plus 2 is 36. The answer is E. And I can go use my calculator to add these numbers up, but I'm feeling pretty good about this. Yeah. Yes, that's the part of the Simpsons rule. Delta x over 3. Trapezoid rule was delta x over 2. And midpoint rule was just delta x times f of all the internal midpoint. Questions? Does that make sense? Look at the next one. All right. Center of mass, centroid problem. Given that the total mass is 32/3 rho, calculate the x-coordinate of the center of mass bounded by the region y equals 0 and y equals negative x squared plus 4x. Hint, draw the graph of the region. Well, I'm going to go ahead and do that. And again, I have my calculator in case you don't know what this graph is going to look like. So I'm going to go to y equals, clear out the old stuff there. Here it is. Y is equal to negative x squared plus 4x. And I'm just going to do a zoom 6, negative 10 by 10, negative 10 by 10 screen here. It's a parabola going from 0 to 4. So here it is. Here's 0, 1, 2, 3. Here's 4. 1, 2, 3. Okay, going from this point to this point, it's an upside down parabola. So it looks like this. Y, X. Okay. And they want me to find the x coordinate of this guy. It's going to be somewhere in there. So remember your formula. To calculate your centroid, center of mass, centroid, x bar, comma, y bar, this is what you need to remember. X bar is equal to the moment about the y divided by the mass, and the y coordinate equals the moment about the x divided by the mass. The other things you need to know is this. The mass is equal to density, which is rho, times area. And you can write this as an integral of top minus bottom dx if you want to. The moment about the x-axis is the tendency to rotate around the x-axis. The functions in terms of x, so that's the disk-washer method. That's going to be rho over 2 times integral from a to b, whatever it is, of your top function f of x squared minus your bottom function g of x squared dx. Just trying to remind you of the formulas you were supposed to have memorized on this. And the moment about the y-axis is the shell method, which instead of pi is equivalent to rho over 2, so 2 pi is equivalent to rho times integral from a to b of your point radius x times f of x top minus g of x bottom dx. Now, I wrote down all the formulas for you guys, but I don't need most of these formulas. What did they give me in this problem? They gave me the mass. What was that? 32 over 3 rho. I want to find the x-coordinate. The x-coordinate is equal to the moment about the y divided by the mass, and I've got the mass. So all I need to do is calculate the moment about the y. The moment about the y is going to be rho times the integral. Remember, this is my region from a to b. That'll be from 0 to 4 of x times your top function. The top function up here is the negative x squared plus 4x minus the bottom function, which is, so this is y equals negative x squared plus 4x. This is y equals 0, which is your x-axis, minus 0 dx. Cleaning this up, the moment about the y would be equal to rho times integral from 0 to 4 of x times negative x squared plus 4x dx. Now, I can distribute this and integrate this guy by hand, but this is on the calculator section. So, just like we did in class, I'd use the calculator to integrate this guy. So this is math number 9, integral from 0 to 4 of x times negative x squared plus 4x, close parentheses, dx. And I end up getting 21 1/3 for you math fraction fans. The moment about the y is equal to 64 over 3 rho. Does that make sense? Now, to get the x-coordinate of this guy, it's the moment about the y, which is 64 over 3 rho, divided by the mass, which is 32 over 3 rho. So the x-coordinate, you invert and multiply. This would be 64 over 3, and then, by the way, the rows end up canceling, times 3 over 32. That ends up canceling, and what do you end up getting? 64 over 32, which is 2, and the answer is 2. Now, I know what you're thinking. Before I finish this problem up, I think they were trying to give you a gift here. Because if I drew my picture, and I looked at this thing, where do you think the center of mass is going to be? Well, this thing's symmetrical. I think it's going to be right about there. And what's the x-coordinate on that guy? Yeah, okay, 2. Yeah, I feel real good about my answer. At this point, I could have figured that out even before actually doing all this math work, which means they must have been nice on this exam. We're going to have to be hard on the next one. So make sure you know your formulas for this thing, because we're not going to give you like this one. That was kind of embarrassing when they get with this problem on the exam. Does that make sense? You can actually look at it and tell the answers even before actually doing all the calculus. But I thought it would be best that you actually saw me do the problem here. All right, here we go. Which of the following is the length of the curve y equals 1 over x on the interval between 1 and 2? Oh, there's another classic one. You make sure you have this formula memorized. Otherwise, I got a 20% chance, because all I'm going to do is guess on it. So, arc length. What is the formula for arc length? Arc length is equal to the integral from a to b of the square root of, help me out here, 1 plus who? The derivative, f prime of x, quantity squared dx. So I've got here y is equal to 1 over x, which is x to the negative 1. So y prime, my derivative would be negative 1 x to the negative 2, which is pretty much negative 1 over x squared, over the interval between 1 and 2. A is 1, b is 2. So this turns into the integral from a, which is 1, to b, which is 2, times the square root of 1 plus my derivative, which is negative 1 over x squared, squared dx. Now, I can clean this guy up, but look at these answers. I mean, they're not expecting you to integrate this one out. They're expecting you to use the calculator on this one. Use the calculator to integrate this guy. So here we go. So I'm just going to put that on my handy-dandy calculator, math number 9. The integral from 1 to 2 of the square root of 1 plus, and I type it exactly the way it looks, parentheses, negative 1 divided by x squared, close parentheses, squared, over error dx. Now, here's the deal. I'm going to hit enter on this guy. And when I do, one of these numbers better show up. Otherwise, I really screwed up. So here we go. What do I get? I end up getting 1.1320900393. Now, it looks like with my answers, they seem to be going for about 3 decimal places. which is 1.132 is what I'm looking at. You see a 1.132? Yes, I do. So I feel good about that guy. Does that make sense? Look at number 7. Okay? So which of the following series converges conditionally but not absolute? So honestly, this is one of those problems where they are actually giving you a problem and you're going to have to analyze each one of these guys, and they are actually going to basically make sure you know the definition of this. Converges conditionally but not absolute. So we're talking about absolute convergence, but we don't want it to converge absolutely. So absolute convergence, again, this idea of absolute convergence, what am I going to do? I'm going to take my series and take the absolute value of it, okay? And so when I'm on this first one right here, this will give me the sum as n goes from 1 to infinity. When you take the absolute value of it, and I'm only going to do this for this one guy, negative 1 to the n over n squared plus 2. You with me? What happens to the negative 1 to the n? What happens to the alternating part? Every time, it's going to go away. That'll be the sum as n goes from 1 to infinity of 1 over n squared plus 2. Now, I'm not going to do the test, but I'm going to do what I call the mental comparison test. And I talked about this with my guys in class, is you got to know these formulas, direct comparison test and the limit comparison test. You just got to know who to compare to. So I do squiggly equal to, who would you compare this guy to? The sum of 1 over n squared. With this guy, P series, P equals what? 2, which means it's convergent, which means this guy is actually absolutely convergent. Not the guy we want. We don't want it to be absolute convergent. We want it to be conditional convergent. So this guy is not him. What about this guy? Here we go. When I do the absolute convergence on this guy, the absolute convergence, this would be the sum as n goes from 1 to infinity of, absolute value gets rid of the negative 1 to the n, that makes it 1 over 5n plus 1. Now, who would I compare to on this guy? This 1 over n. What's that guy's name? And what does the harmonic series do? A divergent. So this is not going to be absolute convergent. So here's a good choice. But here we go. This will be the sum as n goes from 1 to infinity of, basically putting this guy on there, negative 1 to the n over 5n plus 1. When I do the alternating series test on this guy, let's see if he converges. Well, the Bn is the 1 over 5n plus 1. So, got to test two things. Number one, I'm going to test, make sure the terms decrease. N equals 1, n equals 2, n equals 3. That's 1 over 6, 1 over 11, and 1 over plugging in 3. That's 16. Yep, the terms go down. And with number 2, when I take the limit as n approaches infinity of this 1 over 5n plus 1, I get 1 over infinity, which is 0, which means it is convergent. This guy is not absolute convergent, but by the alternating series test, it is convergent. We call this guy conditional convergent. This is actually my answer. Now, just because you need to practice, and this is the final exam, let's explain why the rest of these guys are going to be a problem. Letter C here. If you look at the absolute value of this guy, absolute value, okay, this will be the sum as n goes from 1 to infinity of n squared plus n plus 3 over 4n squared plus 1. I happen to notice that the degree of the top is the degree of the bottom. So the limit of the an would be equal to 1/4, which is not 0. This thing is going to diverge by the divergence test. Does that make sense? This thing completely diverges. It's not going to converge. Does that make sense? This guy here, in terms of absolute convergence, again with the absolute value, this is the sum as n goes from 1 to infinity of 1 over n factorial. Got a question for you. Again, reviewing for the final exam. If I gave you this series right there, what test would you have to use on it? Ratio test. Factorials or powers of n, you got to use ratio test. I used a ratio test, but I gave my students a real clue on this one. Where's that factorial located at? And what happens when the factorial is on the bottom every time? It always converges. Factorial on top, it'll almost always diverge, except maybe that one point when it adds up to 0. But when it's on the bottom, it's going to converge always. This thing is convergent always, so it's convergent, absolute convergent. This one right here, I happen to notice I've got the natural log of n on this one, -1 to the n over 8. On this one right here, let's see here. Oh, I know. If I sit there and do the absolute value on this guy, I sit there and get the sum of natural log of n plus 3 over 8. And again, I happen to notice that if I take the limit as n approaches infinity of the sequence part, natural log of n plus 3 over 8, what's the limit? What's the natural log of infinity? That's equal to infinity, which means this thing's not going to go to 0, which means it is going to be divergent. And so this thing will never go to 0, so which is not 0. So even if I use the alternating series test, this thing is still going to be divergent. And that one, that guy's out. Yeah, I told you before, the answer was B. We got that one. But it was great to review. But speaking of that, and speaking of things like ratio test, take a look at number 8 here. Okay, question. Yeah. That's if I actually did the test. Now, you're right, but I stopped short because they didn't require me to, they didn't say show my work on doing the test. And I mentioned that before. I just have to know what to compare it to. And if I pick out the right guy to compare it to, they're going to do the same thing, whether it be the limit comparison test or the direct comparison test. On this one, I think I can do the direct comparison test because if I add 2 to the denominator, makes the denominator bigger, makes the overall fraction smaller, that's actually going to be less than 1 over n squared. This guy converges, that forces that guy to converge. I mean, I can do the test, but that's not what I need to do. Yeah. D. All right. Well, when you do the ratio test on D, this is what I taught my students. When you do the ratio test, because you got a factorial there, you're going to have an extra n left over. And because the factorial is in the denominator, you're going to have an extra, I think it's going to be an n plus 1 in the denominator. When you take the limit as n approaches infinity, the infinity is going to be in the denominator. And what is in the denominator? 1 over infinity is 0. Your L will be 0 on the ratio test every time, which is always less than 1. That's why it's always convergent. That's actual proof of it. Okay? So let's take a look at this guy. This one right here is you were supposed to figure out the power series. And I mentioned this one to my students before. This one doesn't have a factorial, but again, if it had a factorial in the denominator, what would the answer be? If this is a power series and you got a factorial in the denominator, what is the interval of convergence? All real numbers. It's always going to converge. If the factorial was in the numerator, what would my interval of convergence be? A single value, and it would be actually x equals 3. Does that make sense? The location of the factorial is what we were talking about up here, makes a difference on this problem, whether you get all real numbers or just a single point. This one doesn't have a factorial, so I actually have to do the ratio test. So to find the interval of convergence on a series, with those words, to find the interval of convergence is use the ratio test. So the ratio test is the limit as n approaches infinity, the absolute value of an plus 1 over an. This is equal to the limit as n approaches infinity of the absolute value of x minus 3 to the n over n plus 1 over n plus 1 times 5 to the n plus 1 divided by an, which is x minus 3 to the n over n 5 to the n. So you want to clean this guy up. So this is equal to the limit as n approaches infinity of x minus 3 to the n plus 1 divided by n plus 1 times 5 to the n plus 1. Invert and multiply. This n is going to show up on top. That 5 to the n is going to show up on top. And the x minus 3 to the n will show up on bottom. Invert, multiply, and group together like terms. Now, powers of n and factorials cancel each other out on ratio test. I got x minus 3 to the n plus 1. That's the same thing as x minus 3 times x minus 3 to the n. So here, the x minus 3 to the n's are ending up canceling. Here, 5 to the n and 5 to the n plus 1. 5 to the n plus 1 is 5 to the n times 5. The 5 to the n's end up canceling. So I'm left with the limit as n approaches infinity of the absolute value of x minus 3 times n divided by 5 times n plus 1. Now, take your limit as n approaches infinity. What is the limit as n approaches infinity of n divided by n plus 1? What will that go to every time? That's going to go to 1. L'Hopital rule it, whatever you got to do. This will give you x minus 3 over 5. But this is the ratio test. To make him converge, the ratio test, the L part, has to be what? Less than 1. Solving this guy, do the double-sided inequality. Negative 1 is less than x minus 3 over 5, which is less than 1. Solve for x in the middle. Multiply by 5. Negative 5 is less than x minus 3, which is less than 5. Add 3 to all sides. This will give me negative 2 is less than x, which is less than 8. So here is almost my interval of convergence. And what a surprise, the rest of them are between negative 2 and 8, but I just wanted to show you where you should get this from. But what's the last thing you have to do when you're using the ratio test? Provide interval convergence. Test the endpoints, because that's where L equals 1 and the test is inconclusive. So I've got 2 points to check here. X is equal to negative 2, and the other point is x is equal to 8. Plugging in x equals negative 2 into my series, this will be the sum as n goes from 1 to infinity of negative 2 minus 3 to the 5th over n times 5 to the n. Clean them up. This sum as n goes from 1 to infinity of negative 5 to the n over n times 5 to the n. Negative 5 to the n, I can pull off for negative 1. This will be the sum as n goes from 1 to infinity of negative 1 to the n times 5 to the n divided by n times 5 to the n. The 5 to the n's end up canceling, and on this guy, you get this series. The sum as n goes from 1 to infinity of negative 1 to the n over n. What kind of series is this guy? Alternating series. So I'm going to use the alternating series test. The Bn part is the 1 over n. So when I check it out, I'm going to check two things out. Make sure that my terms decrease. N equals 1, n equals 2, n equals 3. That's 1 over 1, 1 over 2, 1 over 3. Yep, they decrease. And number 2, when I take my limit as n approaches infinity of the Bn, that's the limit as n approaches infinity of 1 over n, which is 1 over infinity, which equals 0. The terms decrease and the limit goes to 0, so by the alternating series test, it is going to converge. To show convergence, I'm going to put it equal to right there with the negative 2. Now, the other point is I'm going to check x equals 8. That'll be the sum as n goes from 1 to infinity of 8 minus 3 to the n over n times 5 to the n. Now, this turns into the sum as n goes from 1 to infinity of 8 minus 3 is 5 to the n over n times 5 to the n. The 5 to the n's cancel, and you're left with the sum as n goes from 1 to infinity of 1 over n. Pay attention to this. When I do take the two endpoints, I'm expecting to get a very similar series, except one side alternates and the other side doesn't. What's this guy's name? Harmonic series. The sum of n goes from 1 to infinity of 1 over n is the harmonic series. And what does the harmonic series do? Diverge, which means we do not want that point x equals 8 into my interval convergence. So this would be my answer. Negative 2 is less than or equal to x, which is less than 8. Negative 2 is less than or equal to x, which is less than 8. The answer is A. Does that make sense? Okay, next problem. Okay, so in this next problem here, we got a power series. We want to find a power series representation for x squared over 1 minus 3x. All right, this was that idea of using the geometric series. A over 1 minus r is the sum as n goes from 0, you use the new and improved version of this guy, to infinity of a r to the n. So when I compare these two guys here, I can let you know that a is equal to x squared, and r is equal to, the one matches up, the negative matches up, r is equal to 3x. So in terms of writing this as a formula, as a series, this is the sum as n goes from 0 to infinity of a, which is x squared, times r, which is 3x raised to the n. Now I'm going to clean this guy up. So this is the sum as n goes from 0 to infinity of 3 to the n times x to the n times this x squared. I'm doing it in steps here so you can see this guy. So this becomes the sum as n goes from 0 to infinity of 3 to the n x to the n times x squared is x to the n plus 2. Does that make sense? Now, that is my formula, and that was good practice on showing you how to clean up a series in case you're asked to do that. But they wrote it out in terms. N starts at 0, so this will be equal to n equals 0, n equals 1, n equals 2, n equals 3. Let's see what we get. 3 to the 0 power is 1. 0 plus 2 is 2, so that gives you x squared. Plug in 1. 3 to the first is 3. And 1 plus 2 is 3, so it's x cubed, and that's going to be a plus. Plug in 2. 3 squared is 9. 2 plus 2 is 4, that'll be x to the 4th, plus dot, dot, dot. And I think I can figure it out from there. I got to have an x squared plus 3x plus 9 to the 9x to the 4th. Yep, the answer is going to be D. Does that make sense? Number 10. A cable that weighs 3 pounds per foot is 40 feet long and hangs off of a tall building. How much work is done in pulling the cable to the top of the building? Hey, great, a chapter 7 question here. All right, so here we go. So doing this particular problem here, I've got a long building. It doesn't matter, as long as the rope is hanging over here, I'm gonna let it hang right down here. So I got this rope hanging all the way down the building, right to the bottom here. So this is 0. How long was my rope? I'm going to call this 40 up here. It could have been up here at 100 for all I care. The height of the building is not going to matter. I just need the bounds on this thing. And I got my dude up here who's going to be pulling up my rope and stuff, okay? So, now, this is my y-axis right here. So here's 40. And so work is equal to the sum of the delta force times the distance that I have to lift. So I made this thing 40 feet tall. I could have made it 100, but it really depends on the bounds here. So your delta force is equal to the weight of cable times how much cable, which would be delta y. So if I come over here and analyze a little delta y slice, this thing weighs, what was it? 3 pounds per foot. It's kind of a hefty cable here. So my delta force would end up being 3 pounds per foot times delta y, because that's how much feet I have here. So your delta force is equal to 3 delta y. So delta force would be 3 delta y. So work would be the sum of the delta force, 3 delta y, times the distance that I have to lift. This was at an arbitrary y level. Where are we trying to lift it to? Now, you had to put this on there, and it didn't matter. I could have made it 40, 80, or whatever. Okay, and I'll show you that in a second. But I put mine at the top of the rope, which is at 40. So what's the distance I have to lift? 40 minus y, top minus bottom. Very good. Converting this into an integral, work equals the integral of 3 times 40 minus y times the delta y turns into a dy. Summation turns into the integral. And then I integrate over where the rope is, from 0 to 40. Does that make sense? And again, I'm going to use my handy-dandy calculator to make it short on time here. So this would be math number 9, the integral from 0 to 40 of 3 times 40 minus x, close parentheses, dx. And I end up getting 2,400, and that would be work. So based on my units, that would be foot-pounds. The answer is 2,400 foot-pounds. I just want to show you this because this messes people up. Well, what if you made the height of the building 100? Fine. Make it 100. What would that change on this problem? It would be, instead of 40 minus x, it would be 100 minus x, right? But then what would my bounds be? The rope is only, or cable is only hanging off over 40 feet. So if this was 100, and the thing was 40 feet long, what would be my bottom bound? Now if it's 40, wait a minute, hanging from the top, this is 100. You hang off 40, 60. You would integrate from 60 to 100. Watch this. Integrate from 60 to 100, right? Because the top of the building is 100. What do I end up getting? Same answer. It's not going to change if you increase the height of the building because it's all about lifting of the cable. Just want to show you that. Question?
Okay, so
Yeah, top minus bottom, because you pick an arbitrary cut that you made right here, and you're trying to lift this little section. Where are you lifting it from? Lift is always top minus bottom. Your target, based upon where I put it, was 40. This was at an arbitrary y level, because that was where I was making my variable at. So the distance is 40 minus y. Yeah.
So, if you're building a 40-foot rope, would our distance still be 40 minus y?
Nope, it would be 100 minus y if you're hanging it off the top.
So 40-foot rope would really be.
Okay, so that's what I was just talking about here. So if you look at this guy right here, and you made the building 100 feet tall, and you're up here, and you hang off this rope 40 feet. This would be 40, right? But in terms of relative, here is 0 on the y-axis. This would have to be 60, right? So this would be your little delta y slice here. So work is still going to be that integral of 3 times. This is an arbitrary y level up to 100. That's going to be 100 minus y dy. But what would your bounds be? You integrate where the rope is at. That's going to be removed from 60 to 100. And that's, I still got the exact same answer, 2,400 foot-pounds. Another question. Did I factor in 9.8 meters per second squared? No, okay, first off, you don't need that in this one because that's not going to interfere with how much the rope weighs. Well, we know it weighs is 3 pounds per foot. By the way, this is English, I have about 32 feet per second there, but second squared. But the gravity only works when you're dealing density of liquid volume, and that's a pumping problem. All right, here is free points right here. Look at number 11. Free points. Given the Maclaurin series for f of x equals the cosine of x. Honestly, we expect you to have this one memorized. You can derive it if you want to. Knock yourself out with this idea of f of x is equal to f of 0 plus f prime of 0 over 1 factorial times x plus f double prime of 0 over 2 factorial x squared plus dot dot. You can do the Maclaurin series on this guy, but that's not what we're supposed to do. There were 5 of them you're expected to have memorized because they're easy to manipulate. What do we remember about cosine? Cosine is what kind of a function? Even function. So I want to have even powers on this guy. And so even powers, remember x to the 0 is 1. So f of x, which is the cosine of x, would be 1. And it alternates minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6 over 6 factorial plus dot dot dot. So which one is this one? There's only one of them. It's A. By the way, this is even and odds. That's not it. These are all odds. Cosine's even, so that's out. This one's out. And this one is also odds. So if you look at these guys right here, this one's some kind of weird combination. This one is actually some kind of a function like 1 over x minus 1. This one right here doesn't have factorials in it, and it's odd. This is the power series for the arctangent. You should recognize these guys. This is the power series for it alternates. Wait a minute, this one is not. This one is, let's see, this one's arctangent, sorry. This is arctangent. I'm not sure who this guy is. This is arctangent. This one right here is who? Sine. Want you to recognize these guys. There you go. Something you're supposed to have memorized for this exam. All right? That is actually 3 points. What about this guy, number 12? Suppose that you have 20 foot-pounds of work is required to stretch the spring from its natural length of 24 inches to a length of 36 inches. What's the spring constant? Now, so let's look at this guy. We've got this spring attached to this building over here, all right? And over here is the natural length. What was the natural length? 24 inches. And then we stretch it out to a length of 36 inches. Does that make sense? Now look at this guy right here. What exactly is that? 20 foot-pounds. Foot-pound measures what? Work. 20 foot-pounds. We know that work, by definition, is the integral from A to B of your kx dx. Remember, when it comes to springs, you need to know 2 things. Hooke's law, force equals kx, and work, which is the integral of force, is the integral from A to B of kx dx. These are your formulas you need to know about springs. The other thing you got to remember about springs is you need to zero out the natural length. So if the natural length is 24 inches, that should be 0 inches. That would actually make 36 inches. How far did you actually measure this guy? So you subtract off the natural length. 36 minus 24 is how much? 12 inches. But that's bad because it's in inches. What is the standard unit of length in the English system? Foot. So 12 inches is equal to 1 foot. So 0 inches is 0 feet. 12 inches is 1 foot. So here we go. We have 20 is equal to the integral from 0 to 1 of kx dx. Our mission here is to solve for k. Now how do I do that? Well, we did this on our notes in class too. So 20 is equal to, k is a constant, leave it alone. The integral of x, or x to the first power, is x squared over 2, evaluating from 0 to 1. Fundamental theorem of calculus, plug in top minus plug in bottom. So 20 equals k times 1 squared over 2 minus k times 0 squared over 2. Well, 0 pretty much cancels out. So I'm left with 20 is equal to 1/2 k. 1 squared is 1 divided by 2. 1/2 k. Multiply by 2 on both sides, and I get k to be equal to 40. So k is equal to 40, and this is the English system, so that would be pounds per foot. So the answer is 40 pounds per foot. The answer is B. Does that make sense? Remember your spring stuff. Yeah. Trick us up by units having the same numerical value.
Having the same value as both the answer for the units are wrong.
No, we're not, we would, on most ways, we would never do that. But on free response, we would expect you to put the units on this stuff. All right. So now we come to the most important part of showing your work. Now, I try to not miss anything on this exam as I'm trying to review for you guys, but here we go. We got 5 more questions. We traditionally, on a part 3, have 5 questions on the free response part. And some of them have multiple parts. But do not be surprised by some of the questions you have. You know you're going to have to pump something out of a tank. You know you're going to have some kind of Maclaurin series, Taylor series that you're going to have to take a derivative or integrate something or other so you can actually do this stuff. You know you're going to have some volume rotation problem. These are pretty traditional on the stuff that you've been exposed to with this particular set of material we cover. So here we go. First problem, what a surprise. Let us integrate. All right, some free points here as long as you know how to integrate. So look at the different types. The first one, the integral of x squared times the square root of 1 minus x cubed dx. So first things first, showing my work. I don't do square roots. This is the integral of x squared times parentheses 1 minus x cubed raised to the 1/2 power dx. Now this is not a rule I have memorized, and looking at it, my first rule of integration, my first basic rule of integration is use substitution. I'm going to let u equal to inside the parentheses 1 minus x cubed. Then I'm going to do du, the derivative. Derivative of 1 is 0. Derivative of minus x cubed is negative 3x squared dx. There's an x squared dx already in the problem, so I'm going to move my constant to the other side. Divide by negative 3, I get negative 1/3 du equals x squared dx. When I substitute, this will turn into u to the 1/2 power. And the x squared dx is going to get replaced with a negative 1/3 du. The constant goes out front, the du goes in the back. And now I integrate it. Negative 1/3. Integral u to the 1/2 is add 1, u to the 3/2 over 3/2 plus c. Clean them up. This is negative 1/3. When you divide by a fraction and multiply, that'll be times 2 over 3, u to the 3/2 plus c. That would be what? Negative 2/9, u to the 3/2 plus c. And the last thing I'm going to do is back substitution and put my final answer in the box. Negative 2/9 times u was 1 minus x cubed, raised to the 3/2 power plus c, and there is my answer. Does that make sense? Notice I didn't skip a step. We are not, please understand, we're not just grading your answer, we're grading your work connected to your answer. Does that make sense? All right, take a look at the next guy. the integral of natural log of x divided by x cubed dx. Well, this is not a u substitution, because if I let u equal to like natural log of x, there's no 1 over x waiting for it. But the problem is, and it's not u substitution, it's not a rule I have memorized, but integration by parts has got to be a product. So the trick on this one was rewrite this guy. So this is now the integral of x to the negative 3 times the natural log of x dx. So recognize it. It's a product where u substitution doesn't work. Integration by parts. Integral of u dv is equal to uv minus integral of v du. So you got to figure out who's u going to be and who's dv. That's the work we're looking for. U, remember your Lytle principle. U, what are you going to let u equal to? What's the L stand for? Logs. I'm going to let u equal to the natural log of x. And that would force the rest of it, which is the x to the negative 3 dx, to be the dv. Lytle principle. L, logs. I, inverse trig. A, algebra. T, regular trig. And then E is exponentials. That is the order of what you should let u equal to with integration by parts. So now I got to find du. The derivative of natural log of x is 1 over x dx. And v, the integral of dv, the integral of x to the negative 3 is add 1 over add 1, which is x to the negative 2 over negative 2. I plug into my formula, u times v, that'll be the natural log of x times x to the negative 2 over negative 2, minus the integral of v, which is x to the negative 2 over negative 2, times 1 over x dx. That's what the du is. Literally plug it into the formula. Okay? But the next thing is the most important step. Clean it up. So clean it up, negative exponent goes on the bottom. So this becomes like negative 1 over 2x squared times the natural log of x. Just clean them up. Now, pulling that 2 out front, it's a negative 2. That minus with the negative 2 out front, that'll be plus 1/2 the integral. Now, what is x to the negative 2 divided by x? Combine like terms. What's x to the negative 2 divided by x? X to the what? Negative 3 dx. When you divide, you subtract the exponents. That's x to the first power. Negative 2, x to the negative 2 divided by x to the first. Negative 2 minus 1 is negative 3. So integrating this guy, this gives me negative 1 over 2x squared times the natural log of x plus 1/2. Integral of x to the negative 3. Add 1. That gives you x to the negative 2 over negative 2. And then you put your, don't forget, it's worth a 1/2 point, plus c. So then I'm going to clean this guy up. And you can clean him up and make him look good if you want to. That'll be negative the natural log of x over 2x squared. A positive times a negative would be a negative. Now this will be 1 over 2 times 2 is 4. And the x to the negative 2 goes back to the bottom and becomes x squared plus c. And there is my answer. Well, geez, Dr. Taylor, if I left the answer as natural log of x times x to the negative 2 minus 1/4 times x to the negative 2, would you count off points for that? No, we would not. But I'm just trying to clean it up, and this is what we would expect. Try this guy here. I'm trying to integrate a fraction. Integral of x cubed plus 3x plus 5 divided by x minus 1. Okay? So, first thing I noticed that when I'm doing division here, I've got the degree of the numerator is bigger than the degree of the denominator. What do I have to do to integrate that sucker? Long division. When the degree of the top is the same or bigger than the degree of the bottom, we got to go old school on this one and do long division. Your divisor is x minus 1. Your dividend, notice there's a term missing. This is where people screwed this problem up. Bonehead careless error. This is x cubed plus 0x squared, because there's no x squared term, plus 3x plus 5. Now let's play the long division game. What times x is x cubed? X squared. X squared times x is x cubed. X squared times a negative x, negative 1 is a negative x squared. And so then I'm going to subtract, which changes my signs. First term should always cancel. 0x squared plus x squared is x squared. Bring down your next victim plus x, 3x, and play the game all over again. What times x is x squared? Plus x. X times x is x squared. X times a minus 1 is a minus x. but then I have to subtract, which changes my signs. First term should cancel. 3x plus x is 4x. Bring down my next victim, plus 5. What times x is 4x? Plus 4. 4 times x is 4x. 4 times minus 1 is minus 4. Then I subtract, changes your signs. The 4x minus 4x cancels, and you're left with 5 plus 4, which is 9, and this is my remainder. So this will actually turn the problem into, how do I rewrite this long division? You write the quotient. The top part is your quotient, x squared plus x plus 4, plus the remainder is a fraction of the answer. You take the remainder 9 and divide by the original divisor, which was x minus 1 dx. This is the same problem. Does that make sense? Now, integrate it. This is what we were expecting. What's the integral of x squared? X cubed over 3. Plus, what's the integral of x? X squared over 2. Plus, the integral of 4 with respect to x would be 4x. Plus, 9 is a constant. Hold him out front. What's the integral of 1 over x minus 1? That's you substitution in your head. What is it? Natural log, absolute value. Don't forget the absolute value of x minus 1. And then 1 big plus c. And then, of course, this will be graded on GradeScope. Make sure you put your answer into the answer blank. X cubed over 3 plus x squared over 2 plus 4x plus 9 times the natural log absolute value of x minus 1 plus c. Don't forget the plus c either. And let's see here. Hold on, I'm just checking out the answers on this thing here. Did I screw anything up? No, I don't think so. What did they do? 4. Oh, they screwed it up. Okay, never mind. Yeah, question. No, that's just me being neat and organized. But you don't have to put equal to, put your answer blank. Other questions? All right. Take a look at this guy. We've got this region. What a surprise. Y is equal to 1 over x. X is equal to 2. Y is equal to 2. We want to sketch the three-dimensional solid form when the region is rotated about the line. And again, I'm going to be very particular about this because I'm going to try to help you guys out with tomorrow's exam. And then set up the interval that gives the solid. So you just have to set up the interval, but you didn't have to evaluate it. So pay attention to directions on here. So first thing you want to do before you do anything is draw the region. So I've got the function 1 over x. Now that's something you should recognize here. Between x equals 2, all right, so x is equal to 2 is over here someplace. X equals 2. 1 over x is in the first quadrant. It looks like this. This is y is equal to 1 over x. X equals 2. And then we have also y equals 2. So y equals 2 would be right about here. Here's the line y equals 2. Okay? So I got y equals 1 over x. Okay? 1 over x, yep. X is equal to 2, and y equals 2. What region is captured by all three of these guys? And this is where most people died on this problem because they couldn't see where the region is. So here's a line right here. Here's x equals 2 is right here. Where's the region captured by all three of these guys? It's this little region up here. You've got to make sure you see the region that uses all three of these equations. That's the trick right there. Do you see that? Y equals 2, x equals 2, y equals 1 over x. There's my region. It's in here in the first quadrant. All right? Now, here we go. We want to take this region and rotate it about the x-axis. So here's my x-axis. Now let's get this down. My function that defines the region is in terms of x. We want to rotate it around the x-axis. What method am I going to use? Function in terms of x, rotate around x. Disk washer. You got it. Recognize what form you need to use. What is the disk washer formula? Volume is equal to pi times integral of your big functional radius squared minus little functional radius squared dx from a to b. Your big functional radius is from the axis of rotation to the outside edge. This is the line y equals 2. 2 minus y equals 0, which is your x-axis there. 2 minus 0 is equal to 2. So the big radius is 2. Your little radius is from the axis of rotation to the inside edge of my region. So that is the function 1 over x. So that'll be top 1 over x minus 0, which is 1 over x. Does that make sense? So here we go. Volume is equal to pi times integral of your big functional radius, which was 2 squared, minus the little functional radius, which is 1 over x squared dx. Does that make sense? Now, the only thing I got to figure out now is what are my bounds. One of my bounds is pretty obvious, which is 2. I got to find that point of intersection there. That's where the 1 over x actually meets up with the 2. Solving for x, multiply by x on both sides. 1 is equal to 2x. So x would be equal to, what is it? 1/2. So this is the point 1/2 right here. So my bounds are between 1/2 and 2. So 1/2 to 2. And you could clean this up if you wanted to, but you didn't need to. Volume is equal to pi times integral from 1/2 to 2 of 2 squared minus 1 over x squared dx. That is the answer. But I got a question for you. First off, you got a question for me. What you got? How do I find big R? The distance from the axis of rotation to the outside edge of region. So your axis of rotation is the x-axis. If you look at this guy and you're rotating it, right? The big radius is from the axis of rotation to the outside edge of my region. Axis of rotation to the outside edge, and then it's a distance. Distances are always top minus bottom or right minus left. This is up and down, so it's top, which is 2, minus bottom, which is y equals 0. Yeah?
What is saying that we simplify the 2 squared?
You can if you want to. I think we can handle 2 squared is 4. If you put 4 there, we're good with that. We would give you full credit. But here's the question I have for you guys. I want you to draw for me what you just found the volume of. When you integrate this guy, you're going to get some crappy number. What would that crappy number represent? So if you drew this region right here, okay? Now I'm going to try my best to draw in this region. Here it is, right here. Here's my region. Blocked it off right here. This is the region. We were rotating them around the x-axis, right? This is my axis of rotation. So you're going to get this reverse image down here at the bottom. It's going to come down here and do this. It's going to look like this. And then you're going to rotate it. This is what you found the volume of. Does that make sense? Have that ability on the exam. Make sure you understand what you're trying to find the volume of. It's worth points. Does that make sense? Merry Christmas. Look at number B here. Rotate the same region about the line y equals 4. So again, draw this region. So get good at it. We can get one region here. Here's that line y equals 2. Here's my axis, right? Here's the line, y equals 2. It came down here and did this, and came over here, and here was the line, x equals 2. There's my region right here. Okay, it's not quite drawn the scale here, but there's 1/2, there's 2. There's the same region as what it was up there, so I'm just redrawing it. But now, where is the line y equals 4? Drawing. Y equals is a horizontal line up here at 4. This is the axis. Y equals 4. Does that make sense? There's y equals 4. Y equals 4 is parallel to the x-axis. I want to take this same region defined by y equals 1 over x. Okay, I'll put them in there. Y equals 1 over x here. And y equals 2 and x equals 2. But this time I'm going to rotate around the line y equals 4. Y equals 4 is parallel to the x-axis. What method am I going to use? Disk washer again. Function is in terms of x, rotating around something parallel to the x-axis, disk washer. Same variable as the variable of the function to the axis is disk washer. When the variable of the function is opposite to the axis, that's the shell method. So this will also be the disk washer method, okay? And so again, volume is going to be pi times integral from a to b of your big functional radius squared minus little functional radius squared dx. Again, what would your big radius here be? It's from the axis of rotation, but this time the axis of rotation is above my region. And it's all the way through to the other side of my region. This is your big R. It is a distance. Top minus bottom. What's on top? 4 minus what's on bottom. What is this curve right here? 1 over x. So your big radius is 4 minus 1 over x. What is your little radius? It is from the axis of rotation to the closest equation of your region. There's a little r. Top minus bottom, this will be 4 minus 2, which is equal to 2. So plugging it in, volume equals pi times the integral of your big functional radius, which is 4 minus 1 over x squared, minus your little functional radius, which is 2 squared dx, over the bounds of the region. Again, it's between 1/2 and 2. So there's my volume there. The answer would be pi times integral from 1/2 to 2 of 4 minus 1 over x squared minus 2 squared. And yes, if you wrote 2 squared as 4, of course we would accept that, but that's what we're looking at. Question for you. What did you just find the volume of? What would the region, what would this three-dimensional shape look like? So I'm going to come down here as a very special little region right here. Here it is. And here is y equals 2 right here. It looked like this little region right here. So I'm going to kind of darken it up. Here was the axis y equals 4. So above that, you get this equal distance thing looking kind of right here. It's going to go up, and it's going to be, there's your reverse image of it right here, and then it's going to be rotated. This is what you found the volume of on this one. Does that make sense? Make sure you have the ability to envision what these things you were calculating. We're interested in that. I think we're setting you up for Calculus 3 for this three-dimensional model stuff. Welcome to Calc 3. And then the last one on this one is rotate the region about the line x equals -1. So again, my same region here. Here is that line y equals 2. Here's that 1 over x function right here. Okay, there's y equals 1 over x. I'll put them in there. Y equals 1 over x. That's that curve right there. Here is that line x equals 2. There's the same region again. So I'm trying to beat to death a dead horse here. But this time we're going to rotate around the line, which is x equals -1. This is a vertical line. This is now my axis. Does that make sense? My function is in terms of x, but now we're trying to rotate something around that's parallel to the y-axis. What method am I going to use here? They even tell you to use the shell method, by the way. By the way, they tell you to use the disk washer method on both those, and I know they said that, but I'm trying to get you, what if we don't tell you that? Can you figure it out? Because that's what you're going to anticipate later. So, shell method. What's shell method? Volume is equal to 2 pi times integral from a to b of the point radius, things you've got to have memorized, times f of x top minus g of x bottom dx. So, the point radius is from an arbitrary point inside your region, there he is, x, and there's distance between that guy and the axis of rotation. Okay? So your point radius is going to end up being right minus left. That's x minus -1. This is arbitrary point x minus -1, which cleans up to become x plus 1. So this would be 2 pi times integral of x plus 1 times, what is the top part of my function defined to be? 2 minus what was the bottom part of my equation equal to? 1 over x dx. And my bounds, same bounds, from 1/2 to 2. So volume here would be 2 pi times integral from 1/2 to 2 of x plus 1 times 2 minus 1 over x dx. That was the equation we were looking for. Now, last little thing on this one, what would the region look like if you rotated it? All right, so I'm going to redraw this guy. Here he is right here. There's my function as I'm highlighting them in here. But this is your y-axis. Here is your line, x equals -1. So you get the reverse image over here, which looks like this. Okay? And then we're going to rotate it. And this is what you would actually find the volume of. And again, make sure you can do a general shape of what this is actually calculating. Does that make sense? Again, did I lose anybody on that question?
Are we expected to give the general representation of what the shape list looks like?
Yes. You got, again, we're setting you guys up for. next semester, Calc 3. So getting a feel for what you're calculating the volume of, and not just making this as mindless integral stuff. All right, here's another one. Consider the function f of x equals the natural log of the square root of x. Use the trapezoid. Make sure you know all your formulas. Trapezoid to approximate the integral between 2 and 10 of the natural log of the square root of x dx. All right, so here we go. We want to have n is equal to 4. My a is equal to 2. My b is equal to 10. My delta x is equal to b minus a over n. By the way, n was equal to 4. So this will be 10 minus 2 over 4. That's 8 divided by 4, which is equal to 2. So I always like to draw out my little axis here. We're starting at 2. The delta x is equal to 2. So at 2, you start at 2, go over 2, that's 4. Go over another 2, that's 6. Go over another 2, that's 8. Go over another 2, and that's 10. And there's your A, and there's your B. These are my partition points. Now, what do we remember? The trapezoidal rule for, in this case, was 4 partitions. The formula is delta x divided by 2 times f of A plus 2 times f of x1 plus 2 times f of x2 plus plus 2 times f of xn minus 1 plus f of b. Just to remind myself of my formula. So, this would be, my trapezoidal rule would be, T4 would be delta x divided by 2 times f of A is 2, plus 2 times f of x1, that'll be 4, plus 2 times f of x2, which is 6, plus 2 times f of f8, 2, 4, 6, 8, and then plus your endpoint f of 10. But this right here is what we want to see. All right? So this would be T4 would be equal to delta x. What was delta x equal to? 2. 2 divided by 2 times f. F of x is natural log of the square root of x. So this would be the natural log of the square root of 2 plus 2 times the natural log of the square root of 4 plus 2 times the natural log of the square root of 6 plus 2 times the natural log of the square root of 8 plus f of 10, which will be just the natural log of the square root of 10. Do you see this? That's what goes into this blank right here. Give the equation that calculates this value. I do not want to see f of, don't circle this answer. You will get maybe at best 1 point out of all this points that you would have gotten. We want to see what the function is. So 2 over 2, granted you can make that 1 if you want to, but I'll keep writing 2 over 2, times the natural log of the square root of 2, plus 2 times the natural log of the square root of 4, plus 2 times the natural log of the square root of 6, plus 2 times the natural log of the square root of 8, plus the natural log of the square root of 10. This was my answer, okay? Now, I'm going to put this on my calculator, and if I put this on my calculator, I'll end up getting, and again, I put it on my calculator, I got 6.755361509. However, you know what I got on my calculator? I got the program. So I am not going to basically just take my word for that I didn't screw up the problem here. So I'm going to go to this. Y equals, remember the calculator project we did, the natural log of the square root, wrong button there, natural log, y equals the natural log of the square root of x. I pipe in my function, and I'm going to go to programs. I'm going to go to my Riemann sum program, which is, let's do it again, program, execute, Riemann sum program, there it is right there. Let's see here, what was A? A was 2. What was N? What was B? 10. What was N? 4 partitions. And what do I end up getting? And I'm just double checking trapezoid, 6.755361050. I went one more decimal place on it. I'm feeling good. But then it says 6 decimal places. So this would be 6.7553, 1, 2, 3, 4, 5, 6, 6, 2. that would be the answer that we're looking for. This is what we want to see. Because you know what the problem is. Because we know that all the students have the program, as long as you didn't lose it or whatever, that this guy, they're going to sit there and do shady work here, but mathematically, that answer shows up in our blank every time, and I'm expecting full credit. Crap on that. We're not going to give you full credit. We're grading the work on this. This is the work we want to see. Now, take a look at this guy. Recall that the estimate of trapezoidal rule for this guy is, for the error-bound formula, is that for trapezoidal rule is k times b minus a cubed over 12n squared, where k is the maximum value of the second derivative. All right, so here's the deal. Look at the parts. Part number one, we want to find the formula for a value for k for using this n equals 4. So my function here is this. The natural log of the square root of x between a is 2 and b is 10. I want the second derivative of this guy. Now this is where most students screwed it up. You know, you really should clean up this function. So f of x is actually the natural log. I don't do square roots. What's the square root? X to the half a power. And when you take the log of it, where do powers get to go? In front of the log. So really this is 1/2 the natural log of x. Now, take your derivative. What's your first derivative? Derivative of 1/2 is a constant. Derivative of natural log of x is 1 over x. So that's just 1 over 2x, or better yet, that's 1/2 x to the negative 1. What is your second derivative? 1/2 is a constant. Derivative of x to the negative 1 is going to be negative x to the negative 2. So cleaning it up, f double prime of x is going to be negative 1 over 2x squared, right? But to find k has got to be the maximum value, max value, of the absolute value of the second derivative, which will be the maximum value of the absolute value of negative 1 over 2x squared, which will be the maximum value of 1 over 2x squared. So I'm going to go on my graphing calculator here. Y is equal to, and I'm going to type this in, 1 divided by parentheses 2x squared. And now, what are my bounds? My bounds are between 2 and 10. So I'm going to put that in there. Window 2 to 10. I'm going to do a zoom fit on this guy. And I'm going to graph this thing. Here's between 2 and 10. And the graph looks like this. Where would the maximum value be located at? Is it at 2 or is it 10? Should be pretty obvious. It's at 2. So I can calculate the value at 2. So I'm going to plug in 2 into this thing. And I end up getting 0.125. K is equal to 125. If you plug in 2 here, 2 squared is 4, times 2 is 8, it's 1/8. So we would accept K is equal to 1/8, but for you decimal fans, 0.125 is perfectly acceptable. But you need this guy, so now you can answer the rest of it. Use this to find an upper bound for the trapezoidal error for partitions. So here's your formula. Error bound formula for trapezoid is less root of k times b minus a cubed over 12n squared. K was 0.125. B was 10 minus a was 2 cubed over 12 times n. N was 4. They even told you that right there. Squared. Now again, where you know we're screwed this up at? They couldn't put that on their calculator properly. So let me show you. Parentheses around your numerator. 0.125 times parentheses 10 minus 2 cubed. Close parentheses around the numerator divided by parentheses around the denominator. 12 times 4 squared, close parentheses. And I end up getting 0.33333. So your error bound formula for your trapezoidal rule will be less than or equal to 1/3, or pretty much that 0.3333, 6 decimal places. We would accept it either way. But does that make sense? And then the last one, of course, is using the same thing, but they want you to find the smallest value of n to get your accuracy to be within 0.001. So here's your trapezoidal rule method again, which is less root of k times b minus a cubed over 12n squared. This would be equal to 0.125 times 10 minus 2 cubed over 12n squared, but you're going to set that less or equal to your within your tolerance, which is 0.001. Your mission here is to solve for n squared. So I'm going to move the n squared over here and divide by 0.001. I'll end up getting n squared being greater than or equal to 0.125 times 10 minus 2 cubed over 12 times 0.001. Now, I'm going to put that on my calculator. So n squared will be greater than or equal to, and here we go. See, I've already got this thing already set up in my calculator, so I can just recall it back down and change that for, delete this part, whole thing over here. And this is 0.001, close parentheses for the denominator there. So this is me typing it in, 0.125 times 10 minus 2 cubed, divided by parentheses 12 times 0.001, and I get big number here of 5,333.33333. What kills off that square? Square root of both sides. So n has got to be greater than or equal to the square root of my answer there, which is 73.02967, whatever. But I don't care about what kind of decimal you got. It could be a very small decimal, a big decimal. You always round what? Up. And if this was a Simpson's rule problem, you have to round it to the next even integer. Don't forget that. But this is trapezoidal rule, so just rounding it up. So rounding it up means n is equal to how much? 74 was the correct answer. You know there's a pumping problem on this question, so here's a good one. This one's symmetrical. Don't forget about some of those problems we did in class, like a pool on the side that's not symmetrical. You got to put your coordinate axes on there. Question. I'm sorry? I'm confused. The sign of the inequality, right there. Yeah, well, see, I put the n squared over here and divided by this, so this would be less or equal to n squared, but it's like English or Hebrew. You can read it from left to right or from right to left. So if this is less than or equal to n squared, then n squared would be greater than or equal to this number, and I just wrote it that way. All right, so here's the tank problem. So go back and look at all the different kinds of tanks, but also remember, if it's symmetrical, you want to put the coordinate axis down the middle. If it's not symmetrical, you'll put it on the left side, because you always want this stuff in the first quadrant. So here we go. So I've got this classic tank problem right here, and they gave me this. Now, here's the deal. A large tank in the shape of a trapezoidal prism, see diagram, is filled to the top with water. The trapezoid base of the tank has a width of 16, so I put it right down the middle, 8 by 8 there, 16. And the top is 4 feet tall. So, okay, so, excuse me, base tank 16. At the top width is 4 feet across. 4 feet across is 2 by -2 there. Then the tank is 3 feet tall, and it is 10 feet long, okay? So it's 10 feet long. Okay, we know the weight of water is 62.5 pounds per foot cubed. Set up the integral that calculates the amount of work done in pumping all the water to a height of 2 meters above the top of the tank. We were trying to be real nice to you guys to go ahead and help you out with the coordinates. Because any kind of tank problem, first thing you need to do is draw the coordinates. We gave you this one here. So, and we went ahead, this was 16, so it's 8 to -8. This was 4 across, so it's 2 to -2. But 2 feet above the top of the tank makes it up here at 5. 5 is my target. Now, what you need to remember is, what's the formula for work? Work is the sum of your delta force times the distance that you have to pump. Delta force is equal to water weight times your delta volume slice. So, on the water weight, this thing's measured in feet all over the place, so this was 62.5 pounds per foot cubed. If it was the metric system, we would probably tell you the density of water is 1,000. You multiply that times gravity, which is 9.8, you use 9,800. If we give you something like oil or something or other, like in the problem we did in our class, well, we give you the density of oil, you multiply it by gravity, 9.8, and you end up getting the density of whatever liquid. So here it is. But this one's water, so it's 62.5. Now my delta volume slice. Come somewhere in the middle of the tank and make a little delta Y slice, and envision you slicing it. If I slice it, it's it's going to look like this, coming all the way across and come back down again. It's going to make either a box shape or a rectangular shape. This thing happens to be 10 feet long. It is delta y tall. Now the question is, how wide is it? Now, because of symmetry, we put the y-axis down the middle. It's on a slant. Because it's on a slant, you move away from the y-axis, it's going to be x. You move another way from the y-axis because it's symmetric in the middle, that's going to be x. So what's the total distance? 2x. Now, if the tank just looked like this, and I put my coordinate axis on the side, then this would just be x. X by width, which is 10 times the delta y. Does that make sense? But this one's symmetric, so I had to have 2x on this guy. So my delta volume is equal to length times width times height. That's 2x times 10 times delta y, which is 20x delta y. So this is 20x delta y. So I'm going to clean that up. So here I go using my calculator here. 62.5 times 20 makes it 1,250x delta y. Now, back to my formula. Work is equal to the sum of that delta force, which is 1,250x delta y, times the basically the distance that I have to pump. Again, just like we talked about before, this was at an arbitrary y level. We're trying to lift this sheet of water right here to where? 3 meters above the top of the tank. Where's that at? So what's my distance? Outstanding. 5 minus y. This is arbitrary y. The target is 5, so it's 5 minus y. Okay? Now, I got a problem. When I rewrite my formula, that 1,250, the summation turns into an integral. There's an x, there's a 5 minus y, and the delta y turns into a dy. Does that make sense? I got a problem. Big old x in the middle of my integration with respect to y. The only way I can eliminate that x is I need the equation for the edge of tank. Edge of tank equation. Now look at the edge of the tank. It's going through 2 points. What 2 points is it going through? This is the point 2, what is that, 3? And it's going through this point right here, which is the point 80. So it's a line going through the points 2, 3, and 80. Does that make sense? So we need to come up with the equation for the edge, but it's a line. So I need to use the point slope formula here. So here we go. My slope is going to be change in y, 3 minus 0, change in y with the change in x, 2 minus 8. So 3 minus 0 is 3, 2 minus 8 is negative 6, so that gives me what? Negative 1/2. That is my slope. And now I'm going to use my point slope formula, y minus y1 equals m times x minus x1. I pick a point. I like the point 80 because it's nice. So it'll be y minus 0 is equal to my slope, which is negative 1/2, times x minus the x coordinate is 8. Cleaning them up, I get y is equal to negative 1/2 x. A negative times negative will be a plus. Half of 8 is 4. So y is equal to negative 1/2 x plus 4. But I want to plug it in for x, so I need to solve for x. Don't forget to solve for x here. So if I solve for x, I would subtract 4. That would give me y minus 4 equals negative 1/2 x. I'm going to multiply this by negative 2 just to clean them up. This will give me negative 2y plus 8 is equal to x. There's my equation for x. It is equal to negative 2y plus 8, and we plug it in right here. So I end up getting work is equal to 1,250 times the integral of x, which is negative 2y plus 8 times 5 minus y dy. Last thing I got to have is, what are my bounds? Remember what we said before. When you're doing work, you integrate over the part you want to remove. We're trying to remove all the water out of the tank. I believe this tank said it was what? Full of water? Okay. So, yes, it is. It's full of water. So where is the water located at on this tank? Where's the water at? Between what? This is dy. So what are my y variables? 0 to 3, full of water, from 0 to 3, that's where the water is. So the answer for this problem is work is equal to 1,250 times integral from 0 to 3 of negative 2y plus 8 times 5 minus y dy. And then we were supposed to use our calculator to evaluate. And when I put it on my calculator, I get 71,250, but don't forget your units. What would your units be? There. What is it? It's work, so that would be foot-pounds. If this was a metric problem, what would your units be? Newton meters or joules. But this is the English problem, so that's going to be in foot-pounds. Yes?
Is 20 multiplied by negative 2y plus 8 times 62.5 times 5 minus y, like all of that in the integral, is that still kind of valid?
Yeah, sure. I mean, we will take decimals on that. All right, last one. And again, notice it's a chapter 8 question. So here we go. Merry Christmas. They gave you the Maclaurin series for the tangent inverse or arctangent of x. X minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus x to the 9th over 9. Pay attention to the directions. I've seen students lose a point here and a point here all because they couldn't read. It's embarrassing. So read the questions. Now, make sure you have that one memorized, but on occasion we'll give you a freebie here. Here's one. So this is valid for any points between negative 1 and 1. Now, use the expansion to find the first, pay attention, first 4 terms of this guy. So my function is x squared times the tangent inverse of x. So this would be x squared. We got the Maclaurin series for this guy, tangent inverse of x. So I want 4 terms. That's x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7. Okay? There's more terms, but you don't need to write that. All we want is those terms right there. Now clean it up. So x squared times the tangent inverse of x is equal to, when I distribute, this will be x cubed minus x squared times x cubed is x to the 5th over 3 plus x squared times x to the 5th is x to the 7th over 5 minus x to the 9th over 7. Does that make sense? So that's what we want. X squared times the tangent inverse of x is equal to x cubed minus x to the 5th over 3 plus x to the 7th over 5 minus x to the 9th over 7. How many terms? 1, 2, 3, 4. That's what we wanted to grade. Does that make sense? You can put the plus, dot, 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 that's fine, but this is what we're grading on this thing. Now, continue on. Part B, and you saw this even on my last test. It was very consistent on this style of problems. You are mimicking what the programming is on the calculator. Use the expansion in part A to find, just using the first 4 terms, again, they were adamant about this, that we want to approximate the integral from 0 to 1 of x squared times the tangent inverse of x. How does the calculator do it? Well, it actually integrates the Maclaurin series for it, which is the x cubed minus x to the 5th over 3 plus x to the 7th over 5 minus x to the 9th over 7, okay, dx, just using my first 4 terms, between 0 and 1, right? That's what they wanted. So here we go. Now I'm going to integrate this guy. What's the integral of x? Again, show your work. What's the integral of x cubed? Is x to the 4th over 4. Minus what's the integral of x to the 5th? That's be x to the 6th over 3 times 6. Plus what's the integral of x to the 7th? That's x to the 8th over 5 times that 8. Minus integral of x to the 9th is x to the 10th over 7 times 10. Evaluated from 0 to 1. So cleaning it up, this is x to the 4th over 4 minus x to the 6th over 18 plus x to the 8th over 40 minus x to the 10th over 70. Evaluated from 0 to 1. Showing my work. Fundamental theorem of calculus, you plug in top minus plug in bottom. This will be 1 to the 4th over 4 minus 1 to the 6th over 18 plus 1 to the 8th over 40 minus 1 to the 10th over 70 minus, when I plug in 0, okay, I'll do that one a break and you get pretty much 0 there. And then you end up getting, when you put it on your calculator, you end up getting If you like decimals, a fraction's fine. That's 517 over 2520, which is 0.02, excuse me, 0.25, copying on 205. Calculate, copy it off my calculator. This is not too difficult. 0.205 1587302. Okay, so this is what I get, and I will have to prove this to you guys because you won't trust me. All right, so here we go. What's 1 to any power? 1, so that's 1/4 minus 1/18 plus 1/40 minus 1/70. And there's the decimal that I was trying to write down. Or you can go math fraction on it, so that's where I was getting it from. But there's the decimal. But wait a minute, what did they tell me to do? Again, read the directions. 6 decimal places. So running it out to 6 decimal places would be 0.205, 159, 150, and that 87 rounds it up to a 9. That's what we were looking for. Does that make sense? And again, who am I kidding myself? I've got a brain and I've got a calculator on this thing. So math number 9, the integral between 0 and 1. Now, it should not be the same answer, but it should be darn close, of x squared times the tangent inverse of x dx. By the way, what mode should your brain and calculator be in? Always radians, just to make sure. I hit enter. Yeah, I'm feeling good about the answer, but it's not, it's at 0.2 something or other. We only start with four terms. The calculator uses a lot more terms. So this is what we're mimicking the calculator on this thing. And then the last one is this, and this bothers a lot of students, so I tried to put one of these guys on my test number 4. Use the alternating series estimation theorem. Did you notice that my series is alternating here? To find an upper bound for the error in your last answer. All right, so here's the deal. How many terms did we write out here? The alternating series estimation theorem says the remainder for n terms, which is equal to the true sum minus the partial sum, is less or equal to b n plus 1. We use 4 terms, so R4 would be the true sum minus the partial sum for 4 terms, which is less or equal to b4 plus 1, which is b5. I want the 5th term. What would be my 5th term up here? Well, if I got to go back and get the 5th term, see, I didn't use the 5th term on this one. This one was 1, 2, 3, 4, x to the 9th over 7. What would my 5th term be? You're taking this guy and multiplying it by x squared. So the 5th term would have been the integral from 0 to 1 of x squared times the 5th term, which was x to the 9th over 9 dx. Does that make sense? There's my 5th term, and we're doing it up here. We're integrating it. So to take a look at it, I'm going to clean them up for you. This would be the integral from 0 to 1 of x to the 11th over 9. This one was x to the 10th. Okay, so, well, I'm going to integrate them, and so you'll see this in a second. So let me integrate them. What's the integral of this guy? What's the integral x to the 11th over 9? Would be what? X to the 12th over 9 times 12 evaluated from 0 to 1. 9 times 12 is 108. So this is x to the 12th over 108. That's being times there. Evaluated from 0 to 1. And I want you to see this. This will be the next term up. This was x to the 8th minus x to the 10th over 70. Next one would have been plus x to the 12th over 108. It's the next term up. Evaluate it. Plug in top minus plug in bottom. That'll be 1 to the 12th over 108 minus 0 to the 12th over 108, which is 0. So this is 1 over 108. And for you decimal fans out there, here we go. 1 divided by 108 is 0.0092593. Now, how many decimal places they wanted me to round this thing off to? 6. So my error for 4 terms is less or equal to 0.00925. 1, 2, 3, 4, 5. Round that up of 9. 1, 2, 3, 4, 5, 6. And there's the answer that we were looking for. Does that make sense? Was this a hard exam? No. Class average on this particular exam, just to let you guys know, on this particular exam, The class average was about a 72. Let you guys know compared to other previous exams and stuff. Again, not bad, but it still had a very large standard deviation. So study hard on this one, and I will see you guys tomorrow at the exam. See you guys then.